Okay, good morning, everybody. People in Miami, people all over the world, whatever time zone you are. Welcome to the 6th version of the Natural Legal Language Processing Workshop. I am Jerry Spanakis, one of the organizers. I'm an assistant professor in Maastricht University, and I'm joined in Miami with Leslie Barrett from Bloomberg Law and Daniel Pretorch from Bloomberg. And somewhere online, we have Catalina Guanza, an associate professor from Utrecht University, Nikos Aletras from University of Sheffield, and Elias Chalkidis from University of Copenhagen. So the goals of the workshop, if you've been a frequent attender, you know what we are doing. But if you are new, we're trying to bring together people from the natural language processing and the broader CS community with the law community and work together in an interdisciplinary way and develop new applications, come up with new tasks and new ideas in the field, in the blooming field of legal technology, and also discuss challenges and solve problems together. In that scope, the papers we've been soliciting this year, similar to previous years, have been, of course, applications of natural language processing to legal tasks, involving also experimental studies of taking all of our techniques from the NLP toolbox applied to legal text, but also come up with new tasks that solve legal questions with tools we have from NLP, new data sets and resources. We keep seeing more and more papers in this domain, also not just involving English, but other languages and other jurisdictions, demo papers and industrial research applications, as well as interdisciplinary position papers discussing challenges of the domain, involving, for example, also the use of LLMs and emerging topics like how to regulate new technologies and so on. This year, we also had something that the community has been asking for many years, a shared task, which was in collaboration with Darrow and Ben-Shahar, who I see him here in the room. And the goal was to, again, think out of the box and detect legal violations in the wild. So we have a session for that at 3 o'clock and discuss more how the task was formulated and what were the results. There was overwhelming interest, and I really mean it, since the shared task was running over the summer and there were 87 participants from 38 teams in 15 countries. Big thanks to Darrow and Ben for their help and dedication to make this true. So some statistics for the papers, right? We all like numbers. We had 68 direct submissions through our submission website, out of which we accepted 26, and also 5 papers that have been through the ARR procedure, so they had already reviews and a meta review, out of which we accepted 2. Again, we don't look at acceptance rates per se, we just accept all good papers based on the reviews. To this, we added the shared task papers. There is one description paper of the shared task, and 7 teams were invited to submit system papers. Plus, also, we gave room to 5 findings papers from the main conference to present here. None of this would be possible without, of course, the help of the program committee. Some of you have been also assisting there, so big thanks to all the reviewers. We list them here and they're also on the website. Just as a note, each direct submission receives 3 reviews. One of them is from the legal domain, and that's also on purpose, so as to trigger us not just to think about what do all our fancy NLP models mean, but also, what is the impact of this in the legal domain. This is a bit of a self-reference, since if you are following this presentation. It means that you are connected somehow, but for housekeeping, this is the Zoom direct link meeting where you can follow the workshop. We are recording the workshop so that it's available for streaming afterwards. And also we are live streaming this from YouTube. I think the stream works as well. So it will be available as well afterwards. The proceedings, as if you attend the main conference, they are already available through the ACL anthology of all the papers. And that being said, you can subscribe to our YouTube channel. It has all the recordings of previous workshops. Also, this workshop will be, as I said, live streamed and also posted on the channel afterwards. We also have some series of NLP talks that we were held over, I think, the COVID period. It's a nice resource for the workshop and the community. We are on X, formerly known as Twitter. The hashtags we are using are the ones you see here: NLP or NLP 2024, EMNLP 2024, Legal Tech, and NLProc. Use all of them, or if you have other ideas, let us know. Follow also the formal accounts for the workshop. First 10 might get the follow back as well once I stop talking. Keeping in touch, right? We do this workshop not just for going to conference, but also publishing papers, also to create a community. And I think over the years, we have grown a lot. We do have a Slack channel, which you can join from the link direct. We have it here, but also it's on the website available. We do have a Google Groups used mainly for announcements. Of course, we have the website. The other day, I was asked to create a LinkedIn group or a LinkedIn page. So there is something under construction there. Somebody asked me why we don't have a Blue Sky account. We're happy to also create this. But as I was saying to somebody, I'm a bit of a boomer, so I'm happy to help with all this. Or if there's anything else you think it can bring the community together, we're happy to accommodate that. Also, we have two sponsors that also are assisting the workshop flow. Bloomberg is offering a Best Presentation Award, which comes with price of $500 and a fancy gold leaf certificate. It's a Best Presentation Award, meaning that we will follow your presentations throughout the day and announce the award in the afternoon. We'll have to fill the certificate manually, but the gold leaf frame is there. And that's from Bloomberg, as I said. So we thank Bloomberg for their contribution. And also, we have catered lunch. We do offer lunch, which is, again, a gentle offer from the Human Ads, a European ERC project of one of our organizing team, Catalina Guanza. This is the schedule, which probably you should know already, but this is an outline of what is going to happen in the next almost 8 hours. We'll start right after this with the first session, involves paper from the generation, for example, summarization and information extraction. After we have the first coffee break, and we'll follow with a good old favorite topic, the legal judgment prediction and question answering papers. That will take us to the lunch break. During the lunch break, we will offer lunch, and also we'll have a poster session. So every paper gets an oral talk, and whoever wants to present a poster, they can also present a poster. So the poster session will be upstairs in the main room. The numbers will be on the screen. If you need any help, just come see us. After the lunch, we'll have the keynote speaker. It's a tradition, the keynote speaker to be from the legal field. And this is what we've done this year. We have Omri Ben-Shahar, who is, I think, on his way from Chicago to present his keynote. I have a slide on this afterwards. After the keynote, we have the legal lens shared task presentation for half an hour. Second and last coffee break, and then the last session involves topic from retrieval, LLMs and reasoning, and miscellaneous topic that we couldn't fit elsewhere. We'll finish with the Best Presentation Award, as I said, and a very great ceremony for that. This is our keynote speaker. He's a professor of law at the University of Chicago, and the title is Privacy Protection at What Cost? I won't read the topic because, yeah, you probably have seen it, and we are going to hear everything about at 2 p.m. I'm slightly over time, so I just want to finish by giving you some motivation to stay here for the next 8 hours. And borrow this slide from Isabel's presentation about where EMNLP 2025 will be, because there will be a next iteration for NLLP in 2025. It has been already accepted from the central call for workshops from the ACL. And we're happy to confirm that we'll be back for the 7th version of the NLLP with EMNLP 2025 in China. You can expect a call for papers in spring 2025. The workshop is, the conference is also a bit tidy earlier than it was this year and also earlier than last year's NLP. So the deadline might be a bit earlier than this year, but for that we'll have more information soon. Okay, this was the opening info and the housekeeping. I think I didn't forget anything. So without further ado, I think we can move to the first batch of presentations. We have 5 papers on the topic of generation. And I think that the first paper is going to be presented online, which means that I need to stop sharing my screen. Okay. Are the presenters of the first paper ready to start?
We're here.
Cool.
I can't
share your screen.
Sorry? I can't share my screen because it's someone else is sharing it currently.
Yeah, now you should be able to share.
Yeah, I'm sharing my screen right now. Working on it.
Don't see it yet, but
yeah, it's loading a bit. I'm sorry about that. Let me try it one more time. Right. All right, I hope everyone can see our screen. Then I would like to welcome everyone to our presentation about our paper titled Summarizing Long Regulatory Documents with a Multi-Step Pipeline. My name is Mika C, and this paper was created at the University of Utrecht in the Netherlands by Ruby Beek, Michiel Bots, Sjaak Brinkepper, Albert Gett, and myself. So let's dive right away. The paper focuses on the summarization of long regulatory documents. In this paper, the LexSumm dataset was used, created by O'Miller in 2022. This dataset consists out of European legislation documents and corresponding golden reference summaries. The documents are difficult to process and summarize because of their long length and intricacies that correspond with regulatory text. These documents are often over 100 pages long, making it difficult for small-sized language models to summarize them without their context length being exceeded. Therefore, we make use of a multi-step summarization pipeline. This is made up out of one or multiple extractive summarization steps and one final abstractive summarization step. An advantage of extractive summarization is that it captures sentences and information literally, resulting in a factually consistent summary. However, the summary is harder to read and less intuitive as sentences are copied and combined. Abstractive summaries are more coherent and fluent as they summarize text in a human-like fashion, but it also has disadvantages because an intricate understanding of the original text is required, and a summary can be factually inconsistent. In this paper, we aim to explore the advantages of both strategies by combining them into one pipeline. The idea behind this is that the extractive steps find the most important sentences in the text and extracts these. The abstractive step will then create a functional and easy to read summary out of this. Similar architectures have been used before by Pilal et al. In 2020, Klaus et al. In 2022, and Zheng et al. In 2022. The aim of our pipeline is therefore to produce one final summary created by an abstractive summarization model. Our proposed pipeline first chunks the document into chunks in such a way that each chunk fits the context length of the extractive summarization model. Then extractive summarization is performed on these chunks. All summaries are combined and concatenated for either another step of extractive summarization, or they are the input for the abstractive summarization model to create the final summary. This research makes use of various ratio types for the abstractive compression ratio. By changing the ratio type, the amount of extractive steps is influenced, effectively changing our pipeline by using one or multiple extractive steps. In our summarization pipeline, there were two classes of summarization models: extractive summarization models and abstractive summarization models. For both classes, multiple models were used to experiment what setup would work best. The differences between these models were in terms of domain specificity, context length, and architectures. So here we can see the results for all the extractive models with different ratio types. And first, we wanted to see what configuration for extractive model would work best. So by comparing all different extractive model configurations with a baseline BERT model as the extractive summarization model, we hope to find the best performing extractive model first. It could be seen that almost all models with a dependent ratio, meaning one extractive step, outperformed their counterparts with multiple extractive steps. And we found that BERT was the best performing model in numerous metrics. But interestingly enough, not using any extractive steps also provided high scores for certain metrics. For the abstractive summarization models, we see that the performance of encoder-decoder summarization models generally worsens using one extractive step, although this differs per model. This is evident in the results for T5, long T5, Pegasus, and Pegasus X, where the versions without extraction tend to outperform their counterparts with an extractive step. BERT presents a more varied picture, as it differs per metric in which variance scores higher. Something very interesting is that Llama 3, the only decoder-only model in this research, seems to benefit from an additional extractive step, obtaining better results on all metrics when compared to the version with no extraction. We also performed a small-scale human evaluation, which actually showed preference for models which scored lower on the automated evaluation metrics. The evaluators also commented on errors made by the model, such as excessive repetitive words or incorrect information. These two things showcase the need for robust automated evaluation metrics. Now that we've seen the result, there are some important key takeaways that our research finds. The first one being that one extractive step usually provides better results than using multiple extractive steps, and that the use of a general short context length language model for the extractive summarization step showed the best performance. The impact of the extractive step differs greatly per model, and a decoder-only model benefited of the use of an extractive step. And finally, we found that robust automated evaluation metrics are still required and as relevant as ever. So I would like to thank you all for listening and encourage you to take a look at our paper. Thank you very much.
Thank you. Yeah, for taking join questions after, I think, the first 5 papers. So for the sake of time, yeah, moving on to the second paper, which is on-site. Yeah, sure. Let me find it first. Which one was it? Okay. Let me share it on the Zoom.
Right. Hello. My name is Xiaomin Tan, and I'm from Thomson Reuters Labs, and I'll be presenting our paper towards an automated pointwise evaluation metric for generated long-form legal summaries. So to give a bit of motivation as a start, automated evaluation metrics are an important part of developing generative models, but existing research on evaluation metrics has focused mainly on short summaries that are a few sentences long. But in the legal domain, long-form summarization is an important task. For example, if you have a court case and you summarize it, the resulting summary can be a few pages long. So what we propose is an automated evaluation method for generated long-form legal summaries. And this is suited for the complexities of legal text, and it's also interpretable. Our approach is called the pointwise evaluation metric, and it evaluates a generated or candidate summary against a human written reference summary. And it consists of two steps. In step one, you break each summary down into individual points where each point says just one thing. And in step two, you compare the points in the reference and candidates. So for each point in the reference, you look to see if there is a point in the candidate that says the same thing and vice versa. And in this way, you can calculate a recall and precision score for the candidate summary. So this idea of breaking down a text into discrete units and then calculating a score already exists in the literature, mainly in the context of manual evaluation of generated text in a systematic manner. But for the legal domain, there are certain complications and nuances that make it harder to handle. So to give just one example in the interest of time, here on the left, there is a sentence in the orange box that comes from a news article summary. And it says, Chelsea were not awarded a penalty for David Ospina's 51st minute clash with Oscar. So if you want to break this sentence down into units, you would use units of a single clause each. So that's the 3 points that you see in the blue box. And these single clause semantic units work well for news articles, which are based on facts. But in legal text, you have often more complex structures. So on the right, you have a legal sentence, which says the Court of Appeals disagreed with the High Court's conclusion that the listings were not targeted at UK consumers. So if you were to break this down into single clause units, you might get the 2 points in the blue box. But this doesn't capture the full meaning of the sentence. In particular, the second point, that the listings were not targeted at UK consumers, is stated as if it were a fact. But actually, this is the opinion of the High Court, which the Court of Appeals then disagreed with. So to handle these kinds of complications and nuances for legal text, we developed the model specifically for this. As part of the paper, we created a metadata set for benchmarking evaluation metrics, and it's a small data set of 7 UK Supreme Court cases. For each case, you have a human written press summary published by the court, as well as 5 LLM-generated summaries of varying quality. And we manually annotated this data set for point splitting and comparison. And the pointwise evaluation metric can also be automated, of course. And we tested various methods to automate the 2 steps. And we found that the best performing methods involve LLMs. In particular, the one we used was Claude 3.5 Sonnet. And we included in the prompts detailed instructions as well as examples of tricky cases in both few-shot and many-shot regimes. And we tested the performance of these automated methods for both steps individually, as well as the full combined pipeline. And our results are that the LLM-based pointwise method achieves better correlation with human evaluation than the baseline methods. And also, it achieves absolute scores that are close to human scores. And you can see this in the scatter plot, which plots the automated score against the human score. The red points are the pointwise method, and the blue points are one of the baselines. So the red points have not only a narrower spread, but also a best fit line that is closer to the ideal line with unit slope and 0 intercept, which means that the pointwise method gives you an indication of the absolute quality of a generated summary and not just a comparative quality of different summaries or models. And in addition, the method is interpretable and explainable because you can see which points exactly are included and missed. And so you can improve the generated summaries in a targeted manner. So that's it for me. Thank you.
Thank you. And then the next paper, I think it's also online, or oh yes, that's you. Cool. Sorry, not online.
Good morning, everybody. So our paper is on actually question answering for information extraction from large legal texts. But in the process, we end up also discussing a few other things. It's a work jointly done by with my students, Saurabh and Suyog, and I am Lipika De, who is presenting the paper. Okay, so the objective was, as I mentioned, it was we do have large volumes of legal documents from which we want to extract very specific kind of information for legal content analytics, which would be about age, gender of the human entities involved, the human relationships involved within those texts between the different legal entities that are there, and deep dive into the circumstances. So the use case actually was from documents which are with about sexual crimes against children. It's called POCSO Act in India. And that's where all these deep dive into circumstances come in, so that one can use the insights to design better law and also understand what is leading to the crimes. That was the motivation. The challenges, of course, was this was a completely non-labeled data set that's available to us, and the insights are what are required. So we look at whether the large language models can be used in a zero-shot, few-shot situation to get the insights. Obviously, the hallucinations and evaluations are one of the key aspects that has to be dealt with. So this is our overall pipeline. Without going into the details of it, let me mention the two core things. So we started with a RAG, Retrieval-Augmented Generation pipeline, but and just started instruction prompting, and the results were not at all good because legal documents are very long and there are a lot of repetitions and references to outside cases also. So the first thing was we realized the need to summarize, and the summaries, auto-generated summaries, were also not good. So the key idea that we did was we chunked the larger documents into fragments which were more controlled based on what kind of content is there. There is a structure in the legal document itself. It's not very rigorous, but more or less can be followed. That's the first one. So we do a summarization of each chunk and then concatenate the summaries, and then go ahead to do one more round of abstractive summarization using the LLM. And then we do a question answering on the basis of from the summarized documents. The key point about the question answering was that we know that LLMs have this tendency to hallucinate. So what we said was, can we ask the question in different ways and then combine the answers? Typically what legal experts also do. So we call this cross-examine. So we have questions which are there, and then we have paraphrasing of the questions. So initial questions mostly came from the lawyers. Paraphrasing was done using the LLMs themselves. And then we also have a layer of verification questions where we use the answers coming from the first question, then put it in a framework back to the LLM saying, is this supported by the document itself? So for every question or information extracted, we have 6 questions actually asked, 3 paraphrases, 3 verification. And then if a verification is no, then we don't take the answer, only we take the answer if the verification is yes. That's the framework. What we show you now are the results. So the first is about the summary. The key result that we get is, given the whole document trying to summarize, Llama 2 could not even do it. GPT was doing it. But when we compare it against the summary of summaries approach that we are proposing, we find that Llama 2 and GPT are more or less similar about their scores, but Llama 2 is a little better because Llama 2 is actually doing more extractive than abstractive. We also asked humans to evaluate the summary on the readability, etc. A very difficult task because legal experts just want answers and not willing to do a lot of verification. So we could do it on 25 documents, and the scores are here. Results of question answered, because the site from where we were getting it also had short summaries in a way for different parts. So we used those to evaluate the question answers to the questions. The details are there in the paper. Again, these are two types of question. One are objective, like what is the gender of the victim and etc. And there are subjective, like what was the substance of the crime, what was the reason for the judgment of not awarding a bail or whatever. So we do an answer match, and these are the scores that you get, more or less similar, but subjective answers are better by GPT 3.5, whereas objectives are better by Llama, again because of extractive scores. So our future work, we want to exploit this in an ensemble learning framework. What we are doing is we are extracting this information and putting or creating a knowledge graph. We haven't really gone to utilize the knowledge graph for extraction and analytics a whole lot. We have just started on the work, and that's where we are headed to. Thank you very much for your attention.
Thank you. Next is Santos, who is going to share his screen.
Hello. Hello, everyone. So I'm Santosh, and this is a joint work along with Cornelius and Matthias from Technical University of Munich, Germany. And the work is LexSumm and LexDefy, benchmarking and modeling legal summarization tasks in English. The main idea is summarization is like bedrock of, or the main task which lawyers run in a daily basis, where they want to extract some actionable insights from these lengthy, long legal documents. And generally having a benchmark serve as a yardsticks to measure progress. And most of the existing NLP benchmarks such as LexGlue, LexStream, etc. mainly focus on predictive tasks, where we do not have a consolidated generative task test bench to test different models. And the different summarization data sets across different jurisdictions are more sporadic, spread across the community. So we thought as an effort to culminate them and make into a benchmark so that people can test different summarization models, etc. on this. They can test it. This is also different from the existing legal bench or law bench, which are more oriented towards zero-shot or few-shot LLM evaluation, where mostly the predictive tasks are converted into generative tasks and prompted into them. So we curate a LexSumm benchmark, which is designed to evaluate legal summarization tasks in English mainly, which in future can be extended to cover multiple languages, which is 8 different data sets from different jurisdictions such as US, UK, EU, and India are consolidated with a different granularity of input length, summary length, and various compression ratios, giving it a different diverse aspect sets in that summarization data sets. Then current existing models mostly do with LLMs, but if you want to have this small fine-tuned model such as legal specific LexDefy is what we created, because existing models such as our legal BERT, etc. exist, but we say there is a gap in the community to experiment with a generative legal model. So that's our efforts to curate a LexDefy model where we continually pre-train with domain-specific corpus, similar to legal BERT, the same corpus we use for T5 model, and continue pre-train and have LexDefy, a legal sequence to sequence model provided. Just as a sanity check, we also assess LexT5 on the probing task using legal llama dataset, which is linguistic analysis probing task. And we observe, unsurprisingly, LexT5 performing better to T5 because of its legal knowledge pre-training. And we also create this benchmark with different models where we fine-tune different long-range models, specifically existing non-domain specific models such as LED, Primera, and Long T5, where you also do pre-training for longer text. Then there are these frameworks called SLED and Unlimiformer, where the framework tries to adapt the short-range models and just convert them into long-range without any additional pre-training. So we use those frameworks and use T5 and LexT5 underneath. Just to give you some, I'll not go into detail of results, just to give you some overview. Unsurprisingly, even Unlimiformer as a framework is helpful. Even you train a short-range legal text model, and without any additional pre-training for long-range, you can even adapt using this Unlimiformer framework and try to obtain better performance. But we also present, we also know this Rouge metrics, BERT score metrics are not really reliable. We also do some additional case studies which are in the paper to observe what are the error cases these models are doing and how we can try to mitigate them as a future scopes. And we also evaluate some zero-shot models like GPT 3.5, Claude, and observe both of them mostly similar, but have Claude a better performance. But as we also know, these metrics are unreliable. But we also thought these data sets can help people to provide, because you have generations, and we have some legal annotations from data on a couple of case studies, which people use to try coming up with new automated metrics as we go down the line. So this is the QR code. When you want to use this LexT5 models or our data sets as a benchmark, please feel to use it and contribute to the community. Thanks.
Thank you. And last paper of the session, Matthias, yeah, he was too fast and prepared. Go.
Okay, so can you hear me? Can you see my screen?
Yep.
Okay, wonderful. So hello everyone, and thank you for joining this session. My name is Mathias Echeverry, and I am a machine learning engineer at Doctrine. Doctrine is a French legal tech that leverages machine learning in order to access and analyze case law, legislation, and doctrine efficiently. Today, we'll be diving into the automation of legal consolidation process, which often struggle to keep legal information up to date. Let's explore the model and the result we achieved. Legal consolidation refers to updating existing legislative text by incorporating amendment from new legal document. On the right, we have an example of a consolidation. An initial text is debated by the parliament in France, and the modification text is adopted. The process of consolidation occurs at the end to produce a modified text. We introduce a generative approach to automate this consolidation process. Previous work has focused on extracting information from legislative text and classifying modification types. Two excellent baselines were also implemented: span extraction and token classification. More recent advancements allow for generative models to handle complex tasks by interpreting them as generative problems. Firstly, we created a dataset consisting of 5,000 triplets, each composed of an initial text, a modification text, and the resulting modified text. We employed the low-rank adaptation method to fine-tune our model. On the right, we have an example of a training prompt. It is composed of three parts: the instruction, the input, and of course, the response that has to be predicted by the model. We evaluate our model performance using a word error rate metric, comparing the model's generated consolidated text against the expected version. It is typically used in speech-to-text applications, but it is very useful in our case. After fine-tuning our model on our dataset, we led 4 different experiments. The first experiment involved comparing 2 models trained with the same prompt. Training a model exclusively on the response field yield superior performance of 9.4%. We also aimed to study the influence of dataset quality on consolidation performance. The second dataset is a cleaned version of the open source dataset. The result of this comparison highlights the impact of dataset quality on consolidation process. In a third experiment, we studied the influence of the rank of the LoRa method. A smaller rank suggests a limited fine-tuning, but the model with a higher rank trains faster, but converges to a similar value as the other model. Finally, we studied the impact of the size of the language model. We compared 4 open lemmas of 3, 7, and 13 billion parameters. The pre-fine-tuned 13 billion parameter model has a huge performance gap. The box plot of word error is depicted for each model. Our best model in red falls between GPT 3.5 and GPT 4. Our model is good at ending addition and substitution, but has difficulties with deletions. Thanks to our model performances, we went on live automatic consolidation of the bill Projet de loi finance 2024 in France. This bill is proposed every year in October and it is promulgated in late December. It has a high impact because it changes the taxes of the country. The bill is composed of 200 articles made of sections, themselves made of modifications. On the right, you have the pipeline used for consolidating the bill. A part of that pipeline is used to split the bill into article and then into section and then into modifications. We use an existing named entity recognition algorithm from Doctrine to find the impacted initial text in the bill. Our model correctly consolidates 63% of the possible consolidations. On the right, you have the correctness rate as a function of the length of the prompt given to the model. On top, we have our model, and we can see that our model has a peak performance for full prompt length below 1000 tokens, with performance gradually decreasing for larger prompts. On the contrary, GPT-4 below demonstrate consistent performance across varying prompt length. In conclusion, our work demonstrates the transformative potential of generative models for legal consolidation. With a fine-tuned LLM, we achieve significant accuracy in real-time legislative amendment. Looking ahead, we plan to refine this approach with advanced fine-tuning techniques and larger models aiming to further improve accuracy. Of course, thank you for your attention, and I look forward to your questions.
Thanks. We have time for questions for all papers. As we do that, maybe the next batch of presenters, as we said, right, you can either present from your laptop with sharing your screen, that's a possibility, or you can send us an email with your presentation, we'll load it on the computer. If you haven't done this, maybe find somebody from the organizers to help you while we handle the QA. Was there a question? Yeah, I'm coming.
For the last presentation, I wanted to ask, like, how you deal with very long, like these legal documents, and we make amendments to just a small portion. Is the model able to handle it when we give it like a very large context and trying to modify just a very small part in the document? And how are we doing it?
Can you repeat the question, because we didn't hear quite well on remote?
Yeah, I just want to ask, like if there are very long legal documents, right? There are like 20 sections, or there will be many sections, right? So my question is, like, if you just amend like just a small part of a subsection of the larger section, let's say it's a very small part. So how is the model able to handle that? Like, and how are you handling it? Just wanted to understand that.
Yeah, so if I understand quite well, so I'm sharing my screen again. The articles of the bill can be very long, and that's why we split them in order to reduce as much as possible the input, in order to treat more and more cases. And this reduction, this splitting, is done with simple regex, because we have the chance that the bill is highly formatted. So this is a bit of chance for us in order to prevent this case to happen too often. But unfortunately, as you can see, our model achieve 63% of correctness rate, but it is only capable of consolidating the half of the consolidation because its context is too small. On the other hand, GPT-4 has a much larger context size and can handle much more cases. Does that answer your question?
Yeah, thank you so much.
Yeah, you're welcome. Nice question.
Hi, thanks everyone. My question is for LexSumm. Can you elaborate a little bit how you created the data sets and the challenges that you face, configuration and annotation?
So this is most of a collection of sporadic works existing outside, but most of the creations are from the press release summaries, and a couple of them have a couple of strategies. So a couple of them are existing press release summaries were modified into summarization sets. And you have the original judgment and you have a specific press release summary for that. A couple of them are from the CLRC website if it's for US, where they have the civil litigation clearinghouse, where they have in-house dockets and they have reference summary series. So it's a mix of methods. I think the main challenges with summarization if you use an LLM is the style content in it, because I think you can't use a golden summary to evaluate in any case. As I always say, there is no golden label even there, because it's all style. I mean, you write the same summary in a different way, but you don't have an automated metrics to do it. And then we also found that using GPTs as automated metrics have no correlation even. So there's a bunch of area where people can explore what should be that ideal metric even to have a correlation.
Thank you. I have two questions for Xiaoming on the Pointwise summary paper. So the first question is how exactly are the criteria you use to define poise? Like, is it one of the major argument brought by either the plaintiff or the defendant, and then the court should respond to? And then the second question is, it seems like the dataset you use to illustrate your evaluation methods include mostly like good summary, because those are like released by the court itself, right, to the press. So I assume they have to like gone through a lot of proofreading and everything. So do you think that your result are like generalized to potentially bad summary, and you'll be able to identify some bad summary if it's evaluated on like that sort of our distribution?
Thanks for the question. Questions. So for the first question regarding how we define the points, so we had a bunch of rules that we developed that made sense for the legal domain. So for example, a single point would be as small as possible while still not changing the meaning too much. So for example, if you have like a sort of because and therefore structure, where the argument is that A happened and therefore this led to B, you can split it up into A and B separately. If you have multiple factors that the court considered to make a conclusion, you split out the multiple factors into separate points. But if you have something like an if-then, where you have a rule that's defined where if this is the case, then this is the consequence, you do not split that out because those are dependent on each other. So the second question was regarding the summaries in the dataset. So what we actually had in the dataset was just one human written summary published by the court, and that was the reference against which the other summaries were compared. The other summaries were LLM generated summaries with different models and different prompts, and they had different qualities because of the model and prompt quality.
Cool. I'll take one more question. I would like to ask an additional question on this. What do you think would happen if the LLM, if we evaluate an LLM that is much more powerful than LexSumm?
That's an interesting question. So when we used Claude 3.5 Sonnet to do the point splitting comparison, it was because it was kind of the best one that we found for this domain. What we found was that it was pretty good at the splitting when it comes to comparing 2 points to see if they are saying the same thing. Sometimes it still kind of gets confused because there are some nuances in the points. we sort of had developed several methods to so that the final result, when you kind of put the whole pipeline together, was still well correlated. But the actual subproblem itself. Yeah.
Sorry, the microphone is off, but I'm not sure. They say that that microphone is off, or they cannot hear it on Zoom. Yeah, we are fixing it.
It's on, but I was just not.
No, it's for the Zoom. You are holding it fine. Okay, but yeah, let's move to the. Are any. Yeah, we'll check it for the next QA, but yeah. Okay, well, moving on to the next batch of papers on information extraction. The first paper, if I cool, are you the first paper? Sorry, the internet is terrible and I cannot see the papers on my laptop. I cannot see the program because it's not.
Okay.
But you are first. Okay, if you are sure you're first. Sorry, I don't have. Okay. Great. Okay.
No, I haven't.
Okay. So you had. Okay, so I had correctly. Okay. Sorry. Okay, cool. This one. Great. And let me just share the Zoom, and then you are ready. Oh. What? How do I do that? The auto hide.
Okay. Good morning, everyone. I'm Pragya Upadhyaya, Assistant Professor at BITS Pilani Hyderabad campus, and I'll be discussing the work done by my PhD students and the Legal I team back at BITS Hyderabad. So the work is on complex information extraction from legal sentences. So I just want to motivate this work first. So I want to crisis that happened in India due to COVID-19. So due to COVID-19, a number of migrant workers in India lost their jobs. And because of that, they were left stranded. They had to go back home. The problem was there was no transportation. They had to walk back home. So they had to walk back home for many days, which led to various health issues. So this highlights that India still needs a better system to handle issues related to migrant worker population. But what is the issue here? The issue here, our target user group, the migrant worker, they are only oral literate or semi-literate. That means they do not have very high text understanding capabilities. So although there are a number of schemes on labor law which are provided by the government on the internet, they are unable to access it because, this information is buried under text-heavy jargons. So even if you have a bunch of entitlements for different types of users, maternity benefits, provident fund, ways to access provident fund, this group of users are not able to access this information so that they can make their lives better. So this work that I'm presenting, it's a part of a bigger project which aims at making access to this information to this specific user group easier. So our goal is to do complex information extraction. I'll explain what exactly it is in the later slides. But once we do this, then it will facilitate various downstream tasks like chatbots or question answering or document summarization, which can improve the access for our next billion user group. So the idea here is to learn discourse trees from lengthy legal sentences. So as we've already seen in the previous session as well, legal sentences are very long. So in order to accurately understand what are the clauses and what are the relationships between clauses, we need a particular representation, a good representation, and discourse trees are a good representation for that. So here you see this discourse tree representation for this statement. The leaves of these trees are the clauses, and the non-leaf nodes are the semantic relationships that are connecting the clauses. So these relationships can fall under two types, subordination or coordination. Subordination means the clauses that are participating in the relation. One of them is main, the others are satellites. Coordination means all the clauses participating in the relation are the main clauses. So our goal is to exactly learn accurate representations of these discourse trees from lengthy legal sentences. So we propose this idea of linearizing this tree structure. For that, we use a pre-order traversal, and we learn them with the help of large language models. So coming to our experiments, I'll not describe all the experiments. There were a bunch of experiments, but I'll just discuss the ones that are relevant. So we used the Penn Tree Bank dataset. Again, this is not a legal specific dataset. We wanted to experiment with openly available dataset and see how well it does on legal benchmark. So we generated the training set by using Graphene. So Graphene is an existing rule-based discourse tree generator. But the problem is, since it is rule-based, it does not generalize well. So we use that as our training set, and then we attempt to fine-tune BERT and T5 on this data set, as well as we also experimented with few-shot and zero-shot learning on GPT-4. So for few-shot learning, we provided it with 11 examples. Why 11? Because we had 10 such semantic relationships connecting different clauses in discourse trees, in the discourse trees that we learned, and one for none. And we also experimented with zero-shot learning, and there were two types of prompts, restricted and unrestricted. In restricted, we actually explained the steps to generate the discourse tree and also mentioned the kind of relations that the discourse tree could contain. In unrestricted, we did not say anything. We just told that, instructed the model to generate the discourse tree, and it was free to use any relationships that it could. And for evaluation of these trees, we did human evaluation, and we experimented on two types of data set. Indian legal data set, it was crawled from the wiki page on labor laws. And ILDC data set is a separate data set, which is on court judgment predictions. But we wanted to see how well this parsing technique performs on this other type of data set. That is why we used it. And for the evaluation, so we did not find any metric in the literature that directly evaluates discourse trees. Generally, they are used with a downstream application to improve the quality of a downstream application. So we propose these two metrics, TSC and TC. TSC stands for tree structure evaluation, which evaluates how well the structure of the tree is, whether the nodes are split correctly, whether all the information in the sentence is contained. And tree content evaluation evaluates the relation that is connecting various clauses. So we did a strict evaluation. That means if all of these three criteria are fulfilled, only then the tree was marked as correct, otherwise no. Coming to our results, so this is not the exhaustive list of results, but just for the sake of this this presentation. So we see that the few-shot, 11-shot GPT-4o prompting techniques-based construction of discourse tree, it does the best. Well, obviously GPT models, they are the best, but we have T5 and BERT models also performing well. Our baseline was Graphene, the tool that we used to generate the training data. So we see that we obtained substantial improvement over this tool. And yeah, so that is it from my side. Thank you.
Thank you. I found back my internet, so we're moving on to the next presentation, which is remote. So, Dries, whenever you're ready, you can share your screen and start.
Yeah, okay, I'll just share my screen. Am I audible? Is the screen visible? Hello?
Yeah, we can see your screen.
So let me just start my presentation. So hello, so I think my screen is visible. Hello everyone, I'm Dries and I'll be presenting on my paper Information Extraction for Planning Court Cases. My co-authors are Rupesh Mali and Claire Burr. this works based on my master's thesis from the University of Edinburgh. So I'd like to start my presentation. So talking about the challenge with legal documents, as mentioned earlier, that they are often very long and unstructured, which makes them hard to understand and also time consuming to read. So the goal of this paper is to develop an automatic system that can actually identify relevant entities and also relevant labels within our legal documents that can actually reduce the legal search time. The contribution of our project is to create 3 novel data set for the planning code cases that is an NER data set, a multi-label data set that is fully annotated by humans, and then a multi-label data set that was partially annotated by humans and LLMs. So I'd like to go towards the data collection process. So what we did was from the National Archive of UK government, we actually extracted 845 different XML files for cases of planning code cases of England and Wales using the planning code keyword. It can be seen that the XML file could actually be divided into 2 sections, cover sections and main sections. The cover section was used for the to train the NER model, and the main section had multiple paragraphs which should be used for a multi-level classification model. So for the data annotation, what we did was that for NER, we manually annotated 845 cover sections, which had entities, citation, court, judge, and date, location and date. And also for the multi-level data set, due to the time limitation, out of 845 data set cases, we used 400 cases, which got about 59,000 paragraphs. We used 4 labels: introduction, facts, and judgment. And then we also further found that while labeling the data, we identified that while we were separating the paragraphs, there was an issue with it. So I'd like to discuss the issue next. So as we can see in the screen, if there were 2 paragraphs, the first paragraph had contained a CPR, a civil rule, procedure rule, which is in fact a fact. So the label should be 1, but the second paragraph, which had no rules, but if you see it with the context of the upper paragraph, it's actually the statement of the rule. So both of them should logically have facts label as 1, but this was problematic because we didn't have the model didn't have the upper context. So to solve this problem, what we did was we re-extracted the paragraph from the XML document and have to re-annotate the data. That's why we re-annotate the data further. So what we did was we manually re-annotated 2 labels, introduction and judgment. We used Llama 3 model with 18 shots example to annotate citation label, and used ChatGPT 3.5 with 5 shots example to annotate the fact label. We actually tried about 5% of the data points and checked if they were doing good, and achieved about 80% of them had labeled the fact and citations correctly. That's why we use these models. Talking about the experiment setup, we had about 845 different cover sections. We split the data into 70-15-15 ratio for train, test, and validation split. We used this is the training configuration. What the models we used here was LexLM, Legal Robota, Legal BERT, and Google BERT model, and also the evaluation metrics were average precision, recall, F1, and AUCPR for the NER setup. For the multi-level setup, the experiment setup was similar to that, but we had to lower the epoch sizes as well as the stopping criteria. We used multi-GPU environment here, and we experimented with LexML, Legal Robota, Legal BERT, Distill BERT, and Google BERT. And also we added the paragraph context. So while labeling the data, we found that introduction was actually at the beginning of the beginning paragraphs, few paragraphs. Conclusion would actually be in the bottom of them. Facts would actually follow immediately after the introduction, so in somewhere around the early sections of it. So that's why what we did was we added the paragraph number as context. So paragraph 1 and then the whole paragraph. So the paragraph context was added here. We used ROC AUC score, Hamming loss, and F1 score for the multi-level classification tasks. This is the result for the NER tasks. What we can see here was that Legal Roberta and Legal BERT as well as LexML were doing good in about 2 out of 4 different evaluation metrics, while Google BERT, even having larger context, not being the domain-specific model, wasn't doing well at any of the evaluation metrics. And the lower half, you can see the multi-level classification tasks with and without the paragraph context. The without the paragraph context, legal robota was doing best in all of the evaluation metrics, while when we are using paragraph context, it can be seen that legal robota was doing well in Hamming loss as well as F1 score, and legal LexSumm was actually performing well in the ROC-EUC score. The conclusion of using paragraph context and without using paragraph context can be seen here that with using paragraph context, all the scores were actually improving. This is for the re-annotated version of multi-level classification. We had directly, because in the previous experiment, the paragraph context was actually doing well, so we directly added the paragraph context. What we can see from here is that LexLM model was doing good in the Hamming loss as well as the F1 score. Legal robota was doing well in the F1 score as well as the ROC-EUC score, and as expected, Google's Big BERT model wasn't performing well except for the Hamming loss. So the conclusion of this study or this research would be that domain specific, in our case, legal domain specific NLP models were good at evaluating and extracting the entities as well as the labels from the legal information. And also another part what we found was like adding paragraph context actually did help the models to understand the label better, and they performed better. And for our future enhancement tasks, what we can do was that we could use better models like state-of-the-art models like Llama 3.1 and ChatGPT-4 for the data extraction. And rather than just using these models in the planning code cases, what we could do is we can actually improve our scope and actually consider all the administrative code cases. So that's about it from my side. I'd like to thank the EMNLP, the NLLP organizers, as well as the EMNLP organizers, and everyone who's listening and everyone who has directly or indirectly supported. Thank you.
Thank you. And we're moving to the next paper, which I should have the presentation here. This one, right? Yeah, okay, cool. How do I maximize this? Oops. I'm trying to maximize it, but no. What?
Control L.
Control L?
Sure.
Okay, yeah, sorry, we're looking for that. Okay, and let me share it also on Zoom, and then you'll be ready to go. And we hide this as well, which yeah, I don't know how to hide this.
Yeah, there's also a shortcut, but I don't know which one. But you can go
Before it happened automatically, but yeah.
Yeah, it sometimes happens not also, but
Yeah.
you have to click on more
Okay.
and then hide.
Okay, great.
And I'll do this. Thanks here.
Apparently, I'm shorter than the rest of the presenters. So, hi everyone. My name is Vasiliki Siscu from the University of Passau and the University of Constance. I'm going to present the joint work that we did with Abed and Annette in Passau on the automated anonymization of parole hearing transcripts from California. Okay, I cannot. So in California, inmates that are sentenced to life are allowed to ask for parole after a certain time in prison. And these transcripts capture everything that was said during the interview, and they can be requested from the California Board of Parole Hearing, and you can just send them an email and they send you the PDF files. And these transcripts are particularly interesting for us as linguists as they capture dialogue dynamics, but at the same time, we are not very confident with publishing this data, making the data available to the research public if it contains names of inmates, victims, and everyone involved in there. So we tried to automate the anonymization of these transcripts. To do so, we requested 334 parole hearing transcripts, which occurred in 2021, and they all have a standardized format. So the first page of the PDF files captures all of the names of the people that attended, the locations and everything. So that's a relatively cool way that we can leverage to get the data from the data that has to be anonymized from it. So our goal was to develop a tool that detects all of these sensitive information, but not only names, but also organization names or locations that, in case of someone who is familiar with the case, could re-identify whose parole hearing it was. So we want to detect these entities, and we want to uniformly pseudonymize these identifiers to maintain the structure of the transcript itself, to not lose the linguistic information that is in there. To do so, we used a multi-tool approach where we combined several named entity recognition tools. Mostly we used Presidio, Spacey, and the Stanford NER tagger. We decided to combine those three to somehow have a safety net. So in case one of the NERs doesn't capture one entity, the other one could possibly get it. So we would close the gap of potential data leakage. And in the second step, we want to pseudonymize with unique but also more refined labels. For example, one name always should get person number 1. If this person had to spell their name, it would also receive spelled name number 1, and so on. So for entities like locations, we would also refine it further down into state or prison or something like that. So here you can see one of the examples. Everything is away, so you cannot re-identify it, but you can still follow the flow of the conversation, and the numbering of the persons is aligned. We achieve relatively high results on this due to the safety net of 3 NERs working together. For the most important entities which are person names and spelled names and inmate IDs, which are publicly available, we achieve very good results. But there are some entities that still need to be refined, and this is due to either being them organizations, which are often abbreviated and they're not captured in the way we would want the system to capture them. And we also found some limitations. So in case you have a very high profile case which received high media attention, you can anonymize as much as you want. People that know the case will still be able to re-identify whose parole hearing it is. So we're trying to balance a bit this trade-off between privacy protection, but also the data utility for us as researchers. You can find the code online, and in case you have questions, I'm happy to answer them.
Thank you. Next is Andre, who presents from his laptop. Great. Yeah, it's fine. Yeah, just
can you make me can I share screen? Sure. Awesome. Great. All right, we set out to create a benchmark to see how well LLMs could handle the very most basic legal text handling tasks that are required perhaps of a paralegal. not something you'd normally have a lawyer working on. And we found out that it's actually that LLMs are actually very unreliable and very poor at handling these basic legal text tasks. So we realized we were talking about basic legal text, and so we decided to call it the BLT benchmark. Also happens to be the name of a delicious sandwich, so that was a nice treat. Why did we actually start caring about this? Well, we have a couple of years ago, we put out a task that is a statutory reasoning assessment. It's a data set. It consists of 9 sections of the US tax code and 376 handcrafted cases that consist of facts, then questions that require applying the US tax code sections to those facts, and then the correct answers. This benchmark had a very nice moment in the sun last year when Greg Brockman presented GPT-4 and actually pasted in one of our examples. It came up with the right answer, and Brockman declared GPT-4 can handle tax. Well, it actually turns out we went and ran all 376, and he had cherry-picked this. So GPT-4 is actually not good at handling basic text-related tasks like calculating taxes and stuff like that. So we set out to figure out why. And here's an example of one of the things that we found that makes it do badly. So this is something this is a prompt as is that we passed in, well, I edited a bit, that we passed in to GPT-4, and we're asking, what is the text at section 152 D to C? What did it return? A stepfather or a stepmother. Well, we had asked for subsection C. It's giving us the text for D. It's having trouble navigating the most basic parts of just navigating the basic structure. Thought, well, maybe it's a problem with the tax code. So we tried synthetic sections. This is something that we pasted it in. This is a generated section consisting of a bunch of nonsense words. And we asked, what is the exact text at section 1001, C1? And it returned NHS delays. Again, it didn't properly navigate the structure of the statute. We had asked for this. It returned this. Do you really want to rely on GPT-4 to handle serious legal tasks if it can't even handle this sort of stuff? Maybe not. We also tried it with transcripts, which are the results of sometimes very contentious and unpleasant interviews done as U.S. civil cases. Here, we pasted in just 15 lines of text, asked for what is the text on line 7. This should be a no-brainer, right? It returned, question, that's what you referred to, a medical. We'd asked for this, it returned this. Seriously, this is pretty not good. Do you really want to have GPT-4 going through and doing the work of a paralegal, let alone a lawyer, if it can't do this sort of stuff? Well, we created a whole benchmark involving these 3 types of text that I just showed you: number of deposition transcripts, sections of the US code, which is all of the permanent federal statutes, and also those synthetic hierarchical sections involving nonsense words. And we do a bunch of things like, given a site, what text is there? Or given a given text, what site is it at? And also, where is term defined, what term is defined at a site, that sort of thing. And we run it against a whole bunch of different LLMs, and we find that the performance is generally pretty dismal, even for the most advanced models. It's a little troubling. We have, as I said, a benchmark that we use for this. We have test and train splits. They come in a bunch of different sizes, including ones that fit into 4,000 token windows, all the way up to 128,000 token windows. So it comes in a bunch of different sizes. And the available to download. able to hear me drone on.
Okay, now it should be fine again. Yeah. I don't know.
Well, it ended up performing a lot better after fine tuning, and it also did a lot better on the Sarah dataset. So if you're ever doing anything that involves legal work with an LLM, you might consider fine tuning your LLM on BLT. So that's it.
Thank you, Andrew. Next is Alice, who is ready. Yeah, you can share your screen and start.
Share my screen.
Adjust it.
Okay.
Good morning, everyone. My name is Alice, and I'm from University of Arizona. And I'm so excited to share my work with you, which is titled Classify First and Then Extract, Prompt Training Technique for Information Extraction. So let's just dive right in. So what motivated our work was from this question. So how can we extract information from legal documents, such as wills, using large language models in a fuchsia setting? And our target information types was 25 types of entities and 20 types of events. But the problem was that 45 types of information types are just too many to be appended as an example for the prompt. So we came up with an idea, like, what if we first classify a document by information type that is contained in the document, and then retrieve example based on these classification result? And then finally extract information with these retrieved examples. So here's a little more detailed construct model. So suppose we have a input document that states, I give, device, and bequeath my wedding ring and my other diamond ring to my son. So basically this document contains a bequest event. So what we will try to do is first we classify this document using large language model. And the result should state, oh, so this document contains bequest event, but not all the other events. And after that, with these classification result, we can retrieve example relevant to bequest event, and then just append that single example to this prompt and not all the other event types. And with the completed prompt, we can do the information extraction using large language models, and we will get these final result. So this is how we evaluated our approach. We used Dataset that was introduced by Kwok et al. And it consists of wills from 2 United States, Tennessee and Idaho. And the task was, as briefly mentioned, was to extract 25 types of entities and 20 types of events. And for the evaluation, we used 2 models, GPT-4 and GPT-4o mini. And as a benchmark, we had 2 models. First one was a ceiling, in which results from an ideal setting with 100% correct text classification was given. And this was for the theoretical upper bound for our approach. And then the second model was full prompt model. And this contained results from the setting where the prompt contains the examples for all the major event types, not just the one that was classified correctly. So this was set as a baseline comparing to our approach. And for the metric, we used a fuzzy matching. So entities or events matching over 70% with gold data were considered to be correct in our work. So this is our result. The first result is for the GPT-4. And as you can see from these highlighted boxes, in the 5-shot setting, prompt training technique boosts performance in both in-domain and out-of-domain datasets for both entity extraction and event extractions. And these numbers highlights that. And similar tendency was observed in GPT-4o mini as well. As you can see from these highlighted box again, in the 5-shot setting, prompt training technique should outperform full in both entity extraction, event extraction, and for both in-domain dataset and out-of-domain dataset. So what is the key takeaway from this? So when comparing prompt training technique and full prompt, models showed better F1 scores for entity and event extractions when given 5-shot setting. So this means that the prompt training technique outperforms the full prompt approach when sufficient number of examples, like 5 examples, for each type of information. Also found that our approach is more cost efficient than using full prompt because by employing this technique, we can reduce the number of tokens contained in a prompt. And for example, in our evaluation case, the prompt training approach was around 7 times cheaper in input processing compared to the baseline model. So this is fairly cheaper. So this was the end of my presentation. And for more details, please refer to paper or dataset and code repository. And please reach out if you have any questions. Thank you so much for your attention.
You get from flexible. Okay, and the next is Santos. We are running a bit behind. I propose that after Santos' presentation, we take a bit more time for question answers. So we take a 20-minute coffee break instead of a 30-minute coffee break. It's okay with everybody. Yeah, then Santos, which if I remember, it's a findings paper, right? So yeah, go ahead.
So once again, welcome, and I'm Santosh, and this is the joint work along with Apolline and Shiyu, along with Matthias Grabmeier from Technical University of Munich. And I talk on hierarchical curriculum learning for rhetorical role labeling of legal documents. I think the famous problem of legal judgment, predictions, or whatever, we always do not have the segmentation present in the documents because legal documents are generally written in end-to-end fashion. So we always, to proxy the data, wanted some kind of structure information to understand what roles are present in it. So that's what the RRL, which is rhetorical role labeling as a problem does, which tries to assign the functional role of every sentence so that gives us a proxy to understand which data we need to use to curate our downstream tasks. So this can help for various precursor tasks, for your summarization, semantic search, etc. And the general traditional model people generally use is to train a hierarchical sentence sequence labeling where you have sentences given to a network and you finally obtain label for every network. The way generally people train any model, and the key takeaways is to also apply to different training paradigms across. So they generally present these training examples to any model in a random order. So the every question we ask is like inspired by curriculum learning. Can we derive some way where you can order this training example saying these examples are easy, those examples are hard, and try to present examples to the model in a more easy to hard way so that can this model learn effectively? And the main question there is, how do we derive difficulties? We can't obtain human annotations for difficulty. So is there a better ways to obtain? And also to think on difficulty, what do we call as difficult? You can order difficulty by documents. You can order difficulty by outputs. Let's say you have these labels. Maybe some labels are easy to identify, some labels are hard. Maybe some documents are easy to identify, some documents are hard. So we finally propose a hierarchical curriculum learning approach where we hierarchically nest both the curriculums. One is on the document side, we use documents, try to use some difficulty measure to order them from easy to hard. Then inside each bucket over time, we order the labels. If we see the label heat map you see on the top, we first only penalize models if the closed labels are even predicted wrongly. But as we go over time, we make sure the penalization increases so that the model learns effectively. So this is how we nest curriculum on the input side and the output side into a hierarchical manner. And how do we obtain difficulty metrics is the main question. So for the document level curriculum, we use the dataset characteristics. Let's say you have rhetorical shifts on how many times the segmented shifts is happening between consecutive terms. Then we have deviation from expert discourse, which means expert will feel this is like ideal way to write a document and how much this document is deviating. That tells you whether it is written in an easy manner or a hard manner. Then you can derive from data rather than asking expert to give a better discourse. Maybe from data, you can derive what might be a better discourse structure and try to identify deviations, or from a probabilistic way to identify the probabilities and do it. Similarly, for the outputs, we want to understand the pairwise label similarities. Either you can use confusion matrix, which tells us, okay, if the model is getting confused between these two labels, those are more harder. If it is not getting confused, that is easy. Or you can also use embedding similarity of label descriptions. You can understand label descriptions, get them embedding similarities, and try to identify if they are closer, they are difficult. If they're far away, they are easy. And then we try to observe different data document level curriculums, and we find that database probabilistic discourse is giving a better performance across different segmentation tasks. Similarly, with the rhetorical role on the output side curriculums, there is no clear winner, both confusion matrix and embedding similarity performing well. And you mix both of them in a hierarchical nesting that further improves performance. So we want to leverage overall, how do we integrate the difficulty assessment and propose a curriculum fashion from easy to hard learning scenario and give it to the models rather than throwing all the data to the model and expecting model to learn. And we investigate different difficulty metrics without expert assessments and try to derive them automatically. And we expect future legal NLP works to also derive some effective curriculums rather than throwing all the data at models. Thanks.
Great, thanks. So we'll take some time for the break for questions. So we'll turn the camera so that people online can see us. So questions for all papers. Yeah. Everybody's looking for coffee, please.
Sorry. Question for the anonymization of parole transcripts. Right. First, what is really the end goal of this research? How do you see it? Like, what is the impact in your opinion? And the second one, I was thinking about maybe some identification, some identifiers. The relationship between the identifiers can lead to know the identity, not individually. So, how do you think about that?
Okay, so the reason why we requested this data initially was because we wanted to look into the conversation dynamics, this kind of legal dialogue. So there is research planned, and in order to be able to release the data, we figured that it would be nice to have a tool to anonymize this. We cannot request the data and then publish them online on ourselves, but what we can do is we can give a list of transcripts that we requested, and we can provide the tool. So this was the goal that we have with this data, and then we need to remind me the second question again. Sorry.
Yeah. So do you mask single identifiers, right, in order to anonymize? But what I'm thinking is that maybe relationship with other identifiers that you didn't mask can lead to the identity of the person. So you understand what I'm trying to say? Okay.
No, so I mean, we try to capture as much categories as we could identify after a manual review of the transcripts. So, I mean, there's always the risk to have leakage, but the categories that we most focus on was names and image IDs and everything that you can get online. I mean, if somebody really wants to re-identify someone, so they will probably be successful with this. So you will never be able to 100% get the anonymized data sets.
More questions somewhere? You want again? Go.
Also to your paper. So I see that's also related to this first question. How I see a shorter potential dilemma up to consideration here. Like the first consideration is, of course, the privacy of the parole inmates themselves, and the second consideration is sort of the larger societal interest in at least being aware of the nature of the crime of the inmates, especially in your case, those was like life sentence parole inmates, right? So I guess the process of like negotiating for parole can be sort of deemed like a renegotiation of a social contract, right? Like the inmate sort of brought a very serious social norm, and then he, according to the social contract, he got that sentence, and then he wanna renegotiate that a little bit. So it seems like society at large should have the right to be aware of the nature of the crime before like making the decision. And you can see like person does like a check for the authority to make sure that they do that representation right. So I guess my question is, how do you like given that potential dilemma between privacy concern and sort of larger being aware of the nature of the crime kind of concern, is the task at hand gonna be like scalable and like have wider applicability?
So I mean, the public can access these transcripts, right? So we're not trying to mask the crimes they did. It's not only the inmates in there, it's also names of family members that are involved or victim names and so. So we're not trying to only protect the privacy of the inmate. So yeah.
Cool. Any last pressing question? Okay, then yeah, Leslie, yeah, you have the mic, or yeah, where is the mic? Yeah, just throw it.
For the BLT paper, it was interesting to see your findings, but what's your opinion of why BLMs have trouble there? I mean, one theory is that they're just not very good at identifying what I call meta-linguistic information. So for example, they're not very good at extractive versus abstractive summarization. They're not very good at finding a sentence in a paragraph that does a certain thing, whereas they to generate very, very well to that. So do you have some thoughts on that?
That's a great question. We actually hadn't thought about why LLMs weren't very good at that. We just tried to probe as much as possible where LLMs fell short of basic work that paralegals would be expected to do, and retraining data hopefully to make them better at that. I think all the reasons that you mentioned there are very likely why what's going on. We didn't explore that for us.
Cool, thanks. So yeah, we can discuss more in the coffee break. So there is a coffee break now, at least for people in Miami. We'll be back at 11. So you have 11 Eastern, right? So we have a little bit more than 15 minutes.
Great. Well, welcome back. That was a fabulous session. And we have another even more fabulous session coming up, I promise. So this session is going to focus on two emerging trends in this field I think are really important. One is legal judgment prediction, which has become increasingly popular, increasingly accurate, using different models all the time. We're going to hear something about that. And then afterwards, we're going to hear about legal question answering, which is another topic, obviously not confined to legal data, confined to all kinds of textual data. So I think we're going to have some really interesting discussions about that. So without further ado, I know we're running a little bit behind. We're going to get started with the first talk right now, which is online. And please take it away.
Yeah. Hello, everyone. I suppose I'm audible. So yeah, I'm Subham Kumar Nigam. I'm from IIT Kanpur, India. And we are presenting the paper Rethinking Legal Judgment Prediction in realistic scenario in the era of large language model. So yeah, let's begin the paper. So our motivation is to see the previous all the works, they are considering the whole judgments. But in the realistic scenario, the judges and advocates, they don't have the whole flow of the case or proceeding. So what we wanted to try here, we only wanted to consider the realistic scenario of the case, which is the fact, statutes, or the some important information of the case. Okay, so let's understand the problem here. So we divided the problem into two parts, which is the prediction and as well as the explanation. So here you can see prediction is the like a binary task. Appeal is dismissed or accepted, is which is oppose or favor of the appellant, and the explanation is the rational explanation of the case corresponding to the decision. So here is the case structure. You can see the first few lines are the meta information of the case, and the and goes on the, and you can see sections and everything, that is the statutes which is cited, and also the previous case is also cited, at the end you can see which is the case outcome is there, like allow these appeals and everything, and correspondingly the explanation of the case. So let's go with the data set and resources. So we have utilizes the ILDC Indian Legal Dataset Corpus, which is published in ACL 2021. And they have the scroll from Indian Kanun website, which is the open source legal search engine. And they scroll from 1947 to 2020. And this is the around 32,000 case from the Supreme Court cases. So we utilizes that, and for the explanation part, we utilizes the ILDC expert, which is the 56 expert annotated golden explanation by the legal experts. Now we are coming to the methodology part. So what we have did, so we use the hierarchical Bayesian CRF classifier to extract the additional information, which is like statutes, precedent, or other key information, and we are appending with the facts. So the problem with this information, because these texts are very long, like legal texts are very long. So what we used, like we use some summarizer like case summarizer, BERT sum, summary runner, or LexSumm to why we did that. So we can accommodate the whole text into 512 token, and we can use some well-known transformer to predict the classification. And for the explanation part, we use the LLMs like ChatGPT 3.5 Turbo or Llama 2 models. So let's go to the prediction results. So what we have observed, like we used different data set like HT, like a hierarchical transformer, like CS, SR, all these are summarized data set. So we observed like this hierarchical transformer giving the best result corresponding to other summarized methodology. And for enhancing prediction with LMs, we use 6 configuration to test these prediction and explanation part. So V1 you can see like this is the only case facts. V2 is the case text plus facts plus other information, which is statutes and precedent. And V3 is the lower court ruling. We are adding V2 plus lower court ruling, and V4 is the legal arguments. And we also did the chain of thought prompting for the deeper reasoning. We observed like the best performance achieved with the V4, which has all the information and plus a chain of thought prompting, which incorporates all the legal elements. Yeah, so the problem with these metrics, these are not reliable. So we given to the legal expert for the better understanding. So we use 2 metric like clarity and linking. So clarity, like how well this explanation is structured and understandable, and linking is how logically the explanation connects with the prediction outcomes. And both the metrics are ranged from 1 to 5, where 1 is the very poor, unclear rational, and 5 is the clear rationals. Okay, so come to the explanation results. So best performance model is like GPT 3.5 Turbo with the full context like V4 plus COT. And V4 plus COT also received the highest scores in both the clarity and linking metric also. And you can see like this we experiment like Llama 2, 13B, 70B, and also GPT-3 Turbo. And here all the metric, this V4 plus COT giving the best performance. Okay, in the conclusion, what we have done, like we added a specific information apart from the facts, also like statutes precedent to improve the prediction accuracy compared to the only factual data. And for prediction, we use hierarchical transformer, which shows the best performance on the best performance compared to the summarized method data set. And for this automatic model to giving the results, we to evaluate the performance, we use the linking and the clarity metric. For the next step, we are using the multi-level classification for the further refinement and model for real-world scenarios. Okay, thank you.
Thank you. Once again, questions are going to be at the end.
Sure.
So next presenters here.
Will we share from here? Is this one? Okay, go ahead.
Yeah, I want to put it, I don't see the F5. I wanted to put this in.
I thought it was control. Oh, control F. Control L.
What is the point of it?
Yeah, that's a problem.
This mouse pad.
Thank you.
Thank
Uh, Good morning. I am pleased to share the results of our most recent project conducted by our team at the University of Cambridge, which includes experts from both the Department of Law and the Department of Computer Science. We have focused on the UKET, which means the United Kingdom Employment Tribunal. Most employment disputes are characterized by power imbalances, and although the UKET does not require the payment of fees and do not require the claimants to be legally represented, it is still true that most of the claimants do not have the legal knowledge which is required to assess their likelihood of winning the case. And this might deter some claimants from exercising their rights. Our motivation for this project stems from the belief that developing an accurate prediction system could greatly enhance access to justice. If the employees were able to gauge the likelihood of winning the case, they would be more powerful when it comes to exercising their own rights. Employers could assess whether their decisions are being fair and legal. Amicable dispute resolution would be greatly facilitated, and it would be easier to identify areas that require legal reform. For these purposes, we had two main goals. First, to develop a large-scale dataset, which should be enriched by legal information automatically annotated through large language models. And secondly, to evaluate how accurately those models would predict the outcomes. So we started with 52,339 cases that we looked for at the Cambridge Law Corpus, that included cases from 2011 to 2023. Of those cases, we eliminated those which corresponded to judgments of only one page because we thought that they would not have relevant information. For each of those cases, we extracted the metadata, and to large language models, we automatically extracted some relevant information, such as the facts, the claims, references to legal statutes, references to precedents, reasons, and the outcome. Now, by looking at those claims and facts as extracted by GPT-4, we were able to detect those facts and claims which were not relevant, not informative, and therefore we excluded those cases. And with that, we got 14,580 cases, which we then split into sets of training, validation, and testing data sets. We then conducted experiments aimed at predicting in 4 different categories the outcomes. In claimant loses, claimant wins, claimant partly wins, or other, based on the facts and the claims as extracted by GPT-4.
For the testing state specifically, we asked the human expert to automatically label the outcome so that we could have a gold standard. We then assessed how models predict with the aim of comparing that with how humans predict. We used for the human task two human annotators that separately predicted the outcomes for each case based on the same set of facts and claims as was given to the models. And they had to first predict and also tell us and write down when the prediction was of low confidence. The results were encouraging. First of all models significantly outperformed random guessing. The fine-tuned T5 model, which was the best performer, still had 19% less accuracy than humans. While most models were very good at predicting when the claimant loses, they were not so good at predicting when the claimant partly won and when the result was other. Finally, both the human and the models had or suffered in terms of prediction score in relation to those cases that were labeled by humans as of low confidence. And finally, when we aggregated the wins and the partly wins outcomes, the results were had a higher prediction across all metrics. I look forward to discuss these results with you. Thank you.
I think we're next, but I'm not entirely sure.
I think you are next.
Yeah.
You are.
Nadine, Tomei. Yeah, this one.
Yeah.
Okay, great.
You're
You have the slides somewhere?
Yes.
Yeah. Okay, you know how control and what?
Control L. You have to hit it really hard because it doesn't.
I don't know what.
Window.
I don't know how that. I think he was just trying to collapse this part.
Yeah, but it's not.
Oh.
Okay. Okay, great. Thank you so much. My name is Nadi Tomei, and I'm presenting joint work with my colleague Ugo Attali. We are from the Computer Science Laboratory of Sorbonne Paris Nord University. We are basically newcomers to this domain, so where we started looking at the literature. There are two main families of models for the legal judgment prediction task. The first one is like almost all the other tasks in NLP. You have a large language model that could be generic one or specifically built for legal text, for example, like a SOL-LM language model, and you do zero-shot or few-shot prediction on some task. And there are also different family where you have like small supervised model. Basically, you take BERT that could also be generic or built for legal text. You fine-tune it on some training data, and then you have your specialized model that could be monolingual or multilingual. But it's an inductive, in both cases, inductive learning framework where you basically have your model BERT. The idea is like you to learn a function from your training data, and you hope that it generalizes to new unseen test data that comes from the same distribution. So we asked the question, is this correct framework to work in, especially for this type of text where the texts are dense and complex, where we don't have a lot of data. And we asked the question, if we reposition ourselves in a transductive learning framework, can we have any improvement? We make this hypothesis and we switch from inductive to transductive learning, where the idea, and specifically graph-based transductive learning, where the idea is that we put all the data we have, all the documents, training and tests into a graph. The structure of the graph captures similarities between documents. And the idea is now not to build a model that generalizes to unseen data, but to classify the unseen data within the entire graph that you see during training. So here, for example, we have the blue and violet nodes that represent train and validation data, and the test data that is in green. Their labels are not seen during training. We build a neural network on this, a graph neural network on this graph, and then we used this network to label the unseen, to label the test data here presented in green. The idea is then to leverage the structure and the similarity between documents to make the predictions. Our approach is really very simple, doesn't add any or very little overhead compared to the inductive method. The idea is that we have all our documents. Here is not one document, but all the documents that are input to some BERT model that can be monolingual or multilingual, can be specialized. We did some tests about this. We get a CLS token representing the entire document out of BERT. And then before building the classifier, we input this into some dimensionality reduction method like UMAP here, which we use. And then we have we use a method to build the graph. The method we choose here is a Delaunay triangulation, which basically constructs the graph by building triangles in the feature space with the idea that no triangle contain any node from the graph. Why we choose this is because this method produces graph that works really well with graph neural networks. They reduce, for example, oversquashing and oversmoothing that are problems for GNNs and really work well in practice. Once we have the graph, we input the graph into a GNN. Here we use the graph convolution networks, and we obtain our model that makes the prediction on the unseen test in the graph. I'll move to the results. So here we did our experiments only on the Swiss judgment prediction dataset. So here we have 3 languages, German, French, and Italian. And we have the baselines here. For example, almost all the baselines are taken from these 2 papers. And we also implemented a baseline using a SOL-LM, which is a large language model. It has 7 billion parameters. The baselines here include BERT and also variation with handle long context, including hierarchical BERT and long BERT. And also we have here 3 baselines that use additional data, for example, machine translated data between languages, adapters on XLMR models, and also cross-lingual training, and also machine learning data, machine translation data. And we see that our approach that compares actually use exactly the same data as this model here, BERT, and achieves a large improvement over all these for all these languages. One interesting thing about this model is that for example, in the Italian language here, we have a smaller training set compared to German and French, but our approach using the graph structure actually reduces the gap that we have compared to other BERT models. The approach is very effective, so the overhead with respect to only using BERT is really small. For example, for Italian, we need only 16 seconds to classify the entire test set. For German and for French, up to 2 minutes, and we have the prediction for the entire training set. That's it. In conclusion, I would like to stress that this approach is really very computationally efficient, no overhead. On the downside, if you have a new batch of training data, you need, test data to classify, you might need to rebuild the model. This is something we would like to test in future work. Are we really required to redo the training, or the model still works well? And we would like also to test scalability to larger data set and other data sets. Thank you so much.
Magic touch. Okay. Control L, you have to hit it very hard. How did you control L? Ah, I worked that.
Great, thank you. Hi, my name is Yeva, and I will present the comparative study of explainability methods for legal outcome prediction that was co-authored with Josef Valvoda and Ken Sato. We believe explainability is important for this task because of the profound effects that using NLP models in the legal domain can have on human life. So we use the dataset of the European Court of Human Rights, where we have the case facts and a label for whether some article was breached or not. For example, Article 8 protects the right to respect for private and family life. So this is an example from a very recent LAR-ECHR case that I will just use as an example throughout the presentation. It's a case where over 2,000 elderly women sued Switzerland over not doing enough to combat climate change. And this has been dismissed by numerous courts, citing reasons such as women over 75 are not the only population group that is affected by climate change. And in the end, the applicants won this case. The dataset also contains silver rationales, which are the facts that are mentioned by the judge when delivering their decision. So, for example, here, the applicants point to various failings in the area of climate protection. And we also use two datasets which have additional annotations for the legal concepts that are present in these cases, such as the precedents, presumption of innocence, and so on. The way we model this task is a little bit different from the usual. We use a three-way classification with the positive class, where some article has been breached, the negative class, where it was claimed but not breached, and the null class, where it wasn't even claimed. We fine-tune legal BERT and long former for this task, and we get fairly decent results, except for the negative class, where the scores are much lower. We use three different explainability methods to find out what are the important facts for the models when making this prediction. The first one is integrated gradients, where we use the information about the gradients in the model to answer the question, why didn't the model predict the positive label in this case? And the answer here would be because the applicants point to various failings in the area of climate protection. The second method is contrastive explanations, where the input is projected onto a latent space that differentiates two alternative labels. So in this case, we would be answering the question, why did the model predict the positive and not the null label? And the answer might be because had the Supreme Court not left it open for an appeal, perhaps these women wouldn't have sued, and then maybe the outcome would be null rather than either of the other two. And the final method is concept erasure, where a given concept is erased from the representation in the model in order to see its importance for the prediction. So here we would be answering the question, would the model still predict the positive label if it doesn't have access to a given concept? The concepts are the ones from the annotations, for example, the precedence of the ECHR, which could potentially be important because in the past, when people sued governments over climate change, they lost, and the judge cites this in this case. In order to evaluate the contrastive explanations and the integrated gradients methods, we run a correlation study, and we find no correlation between the importance scores for the models and the silver rationales. And in order to evaluate the concept erasure method, we compare the model performance pre and post concept erasure. And again, we find no significant difference between the performances. And we take these negative results to indicate that perhaps the models aren't using the type of legal reasoning that human experts would in these scenarios. And we consider this a call for caution when using them. Thank you.
Okay, so I should stop sharing here and you're going to do it on your computer.
Just bear with me for the next 10 minutes, but yeah. So I'm Santosh, and this is a joint work with Mohammed and Stanislaw and Matthias Grabmeier from Technical University of Munich. And this is incorporating precedents for legal judgment prediction on European Court of Human Rights. Given the background has been set on what Court of Human Rights says and what everything is, I'll just quickly get into what the main content is. According to LexSumm nomenclature, we have two tasks present here. One is to identify the set of articles which have been alleged to have been violated, and your task is to define which articles have been violated. So the main modeling paradigms which existed around is to take the facts, give it to a model, and give you the outcomes. We posit that the legal doctrine of stare decisis in that sense, where the prior cases are really important to support your arguments or to postulate your arguments to arrive at a conclusion. In this work, we want to explore how do we leverage this concept and try to involve your previous cases, which are also abundant set of knowledge, in LGP models to predict the outcome. One might ask, why do we even need to incorporate? Because we are even training on the same data. The model wouldn't the model learn that? The idea is also, the problem comes from the definition of tail problem in that sense, where there are some cases which are more frequent is learned by the model. There is this tail knowledge which model may not pick up. So maybe implicitly providing such cases might help the model to efficiently not remember them, but at least learn how to reason when you give new cases. So we investigate two strategies on how do we incorporate these previous cases. One, without any training phase, we directly give those at the inference time without any training and let the model reason with the previous cases and try to arrive at the answer. The next one is during training itself, because the model is not trained to learn that reasoning or comparing and contrasting with the given retrieved cases. Maybe it's better you also integrate during training via some fusion layer where you try to give similar cases during the training so that model, rather than learning any memorization patterns, it can try to learn how to reason with the given cases and try to derive and deduce the final outcome. So to have such an effective precedent retriever, you want to retrieve some semantically similar cases which share the facts with the query case. And to train that, we employ a pairwise similarity loss, where the idea is rather than using one binary label, we want to check if the fine-grained labels are overlapping. We use that label overlap ratio as our retrieval loss rather than just using a binary at the end. Then how do we integrate them? During inference, you try to integrate them using label interpolation, where the idea is to you try to interpolate for every article separately as a binary classification and try to derive final probability and have a threshold on top of it. Rather than that, you can try integrating at training, so that at the training, the idea is you incorporate a cross attention based module where the idea is you have a query case, you have some set of similar retrieved cases, you try to region each of the case and try to arrive at a probability. And then based on that, you can finally reduce the outcome. So here we also train the joint retriever and the LJP model so that they also try to learn coordination between both of them by minimizing the KL divergence loss between those scores. Just to quickly give a glance of results, I'll only be talking on one task, but rest of the task, please refer to the paper there, where the idea is these are only inference integration methods where you can do self-retrieval, that is use just the embeddings of the model to do it, or you use external retrieval methods, which were trained either on binary relevance label or a fine-grained relevance label. And we observed fine-grained relevance label providing a better supervision signal to learn effective retrievals, which ultimately helps in your prediction task. And then when you want to integrate them during training, we find training-based integration is better compared to the inference-only approaches. So where we have retriever frozen and only train LJP model, where you train both of them with an additional KL divergence loss, we observed adding additional KL divergence loss helps both of them to coordinate effectively and know each of others' strengths and complement each other. So that achieved a better performance at the end. So finally, we enhance this outcome prediction task by inspired from this integrating precedence concept. So we train an effective label, fine-grained labels to understand how do we derive relevant signals. And rather than just integrating at inference, we also try to integrate during training because we do not want model to just memorize them, rather want to learn how do you retrieve and how do you coordinate and reason, compare and contrast and deduce the outcome. We find such an joint training of retriever alongside LGP model helped model to arrive at the final predictions. And also from explainability perspective, now this retrieved precedents can also help like an analogical reasoning, trying to understand, okay, this is the facts which are similar to this case. That's the reason we are predicting this. So there is a whole lot of analogical reasoning. We can do experiments to understand how do these precedents really help and are those really the precedents we are looking for, etc. in the future work. Thank you. What can I do now? For more 5 minutes, but yeah. So this is a joint work with Irtiza Chowdhury, Shanshan and Matthias Grabmaier from Technical University of Munich. And it's on craft of selective prediction towards reliable case outcome classification, which is an empirical study again on European Court of Human Rights. So the idea is most of the models try to predict the outcome based on the given facts. Now we want to study from an explainable, rather than studying from the performance perspective, we want to assess how much reliable are these predictions, because we wanted models to be self-aware of whether they know the prediction or how are their confidence estimates. So we want to understand not only the performances of these models, we want to understand how predictions are reliable. And we want to investigate using a framework called selective prediction, where the idea is if the model is not confident, please abstain from prediction rather than predicting something, while also maintaining high coverage. Because if model abstains from all predictions, it doesn't make sense to train it. So we also want to maintain high coverage while abstaining from predictions. So in a sense, we are trying to assess the reliability of model. So the model somehow need to know this self-awareness that when it can acknowledge that it does not know, and it need to differ saying, okay, this is time for humans to do manual inspection. So this is a human hybrid system where we want to assess whether models have this self-awareness capability so that in the selective prediction, it can abstain when the model is uncertain. So technically we finally have this end-to-end pipeline where you have a standard classifier, then you have a confidence estimator. Based on the confidence, you try to either predict or abstain, and which is what we call it as a selective classifier. So ideally, your confidence estimator should be as such. It should give higher confidence for correctly classifications and lower confidence for the incorrect ones. Then we learn a threshold saying that, okay, after this threshold only we'll predict it. Rest of them will try to abstain this stuff. So the main question we want to investigate here is we want to assess different design choices to build such reliable models. Couple of them being how our choice of pre-trained models affects reliability, whether the size of a model really affect any reliability. Can we have a better confidence estimator? And does adding any additional training losses can also help for better reliability? to observe, and we also analyze because you have different tasks with different difficulties. Let's say we have looked upon in the previous presentation task A and B. We also look upon a violation prediction, allegation prediction, which is task A and B. And we also have A given B, which is predict the violation once someone has already alleged the specific set of articles. And we also study the impact on different sets of frequencies of whether the frequent articles are more reliable or less frequent articles are also reliable, etc. And the metrics we use to assess this, classification performance as a macro F1 score, we wanted it always to be higher. Then for reliability, we have these three metrics, which we call as area under risk coverage curve, where we plot the coverage and the risk and try to get the area under it. And then we have reverse pair proportions. That is for every pair of examples, we see whether if it's correctly classified and whether the confidence is higher or it follows an inverse relationship. And we have a refinement, which is more of a calibrated metric. Among these three, the lower is better rather than higher. So just to understand the first, when we want to assess impact of a pre-trained model, the main findings we observe from these different plots, maybe summarizing them very quickly, would be having a domain-specific corpus during pre-training will help your reliability compared to complete absence. But if you only extremely focus on that particular domain corpus, model turns overconfident. So you need to have a mixture of domain corpuses in which you need to have this domain corpus plus another legal corpus so that you can strike a balance between accuracy and the confidence. And we also see larger models are exhibiting overconfidence compared to base models, which is a trade-off between size versus reliability. And how do we estimate the confidence estimations? There are different methods such as softmax response, where you would get the softmax logits and try to say that if you have higher prediction, that might be your confidence score. Then there are Monte Carlo simulations where you try to run with your dropouts different times and try to calculate confidence estimates based off them. Most of the results we saw, Monte Carlo dropout methods enhance better confidence estimations compared to the softmax response methods. But Monte Carlo methods, you need to run them multiple times. It comes an increase with computational cost. So which also throws a question on how can we build effective confidence estimation methods at a cheap computational cost. And lastly, how does the impact of training loss makes on it? We have different estimates, like you only use task-specific loss, or you have you additionally add a confident error regulator so that you don't overshoot the model's confidence. Then you have a calibration error to make the model's outputs calibrated so that it doesn't overshoot its confidence. And then you have a gambler's loss, where the idea is to confuse the model so that it does not shoot for overconfidence. And couple of takeaways from this graphs mainly are adding confidence error regularization is the perfect recipe to have a balance between your performance of the model versus reliability. And then on the label frequency side, we see as the model, as we move towards more frequent labels, the CER adding this confidence error regularization helps. But for the less frequent labels, you don't see effect presenting there. And the Monte Carlo dropout methods are consistently performing better across all the label frequencies, irrespective of whether they're frequent or not frequent. We see this larger models suffer mainly in the rare articles, but it picks up well when you have more frequent because you have larger parameters and you can get overfitted for those frequent articles more. And so this is a work which empirically investigates on 3 different COC tasks with 5 different pre-trained models, 4 confidence estimators and loss functions. This is just to assess how these various design factors contribute to better selective prediction in case outcome classification. I think future works can take these design recipes and investigate into their models, because they don't want only to concentrate on performance. They also want to have these models reliable so that the model has this self-awareness on when it is not confident, it need to abstain and defer back to human. Thank you.
Okay, we can take 5 minutes for questions. The first presentation from the next session is not here, so.
I have 2 questions. The first one is for you. You said T5 is Alex informed in terms of judgments. Were you able to investigate why that was? Thank you. We fine-tuned the T5 model, but we didn't investigate further exactly why. And then my second question was for the last presenter. So You said that one of the approaches that you used was pre-training on precedents at training time rather than introducing them at input time. But wouldn't that increase the upkeep as more precedents come into play? So like, why would someone choose that approach over using the retrieval at inference time approach?
So the idea when, I'm not talking about LLM setup that has a different internal mechanisms to do this RAG approach, but in general, when you only do an inference, the model has been trained to only deduce the outcome given the facts. So you have the skill it's learning is memorization in one extent because it's trying to learn, okay, these are the facts, and then I need to give this outcome. Whereas in the training, okay, in an ideal scenario, what we want to do is you want somehow model to offload that skill. As in, because you need not memorize. We are giving you the information. You just need to compare and contrast with the retrieved stuff so that you deduce the outcome. So adding that at training time will help the model to offload that skill and only pick up those skills that are required to compare and contrast. Whereas if you do at inference, the model may not learn those skills and it is mostly trained for memorization kind of rather than compare and contrast.
Thank you. And then I independent reporter. My question is for the explainability approach, however. So you presented 3 approaches. Which one was more useful from a user's point of view, if at all?
So we have negative results. So so none of them, I guess. Theoretically, we thought the consideration would be the most interesting because it is more in depth rather than looking at surface features of just which fact of the case is important, more looking into the conceptual representation. But since I don't know, since we got negative results, I can't comment much more.
Just wanted to suggest we try just asking ChatGPT to classify and explain, and in different tasks, not only legal text mining, and the user found that very useful this natural language explanation generated. But we try to start to build some knowledge into there, so to guide. So here you have the knowledge, but you have to incorporate it in the output. It's worth pursuing. It's not trivial to do, but a suggestion.
The Zoom question is for everyone, so I don't know if there's anybody wants to jump in on it.
My question is also directed to you. So I think related to the negative result, for the same style as like I did some work in the NLP explainability display, and what I remember is that to generate the same style explanation, like say in math, for example, in the first method, there are a variety of different technical methods to achieve that same style explanation. Like, you use integrated gradient, but I guess there's also like land, shape, and all those typical say math papers. So have you considered like trying different technical underlying methods to generate the same style explanation and like checking if those still like give the negative result, like maybe the negative result is like because of the some problem with the underlying methodology, technical methodology rather than because of the style explanation.
No, we didn't. The only ones we tried are the ones that I presented. So it's possible, yeah, that we could try different ones. Also, the white box approaches, which we haven't tried. But since we got the same results for all of these 3, we do think there's something there that is indicative.
There is a bit of a general question about I think there were this paper were using
The legal precedence paper authors maybe.
Why you didn't use RAG? Anybody wants to take
So the idea of RAG is ultimately there, but the problem of using any LLMs per se is you need to somehow put everything in context. Unless you have some memory modules, etc., to handle different cases at once, you are limited by the context then. which means ultimately, given the context of this Mistral, etc., which you can fit into one or two. But if you go to this 1 million, maybe that's a different story, where people also find this lost in the middle problem, where model generally converges on the first and the last, rather losing in the middle. Then the question being which precedents you need to give importance to, etc., which might be a future work to look into. But currently using this inbuilt external models gives you some way, because you can reason with each of them separately rather than just an in-context way to concatenate all of them in single prompt or something. At least for now, that might be my reason.
Cool. Any more questions? Or I have one question about you guys. Why did you pick this specific graph model that why do you think that had particularly the problem in ham, which was the biggest? Yeah, or do you think had an impact, or will have an impact in another representation?
So your question is about the Delaunay triangulation. So in the previous work by this guy, he showed that this particular triangulation method really works well for GNNs and GCN in particular, because it reduces over squashing and over smoothing. He can probably expand. So the key idea to mitigate over smoothing and over squashing is to avoid highly negatively curved edges that represent that act like a bottleneck in the graph. Because if we have a bottleneck, if we have a large click here and a large click here, connected only by one edges, all the diffusion messages are going to be compressed to go to the other click. So we want to avoid this kind of subgraph in the graph, and the Delaunay triangulation and maximize the number of triangles in the graph allow to avoid this kind of substructure. And also this kind of graph mitigate over smoothing. So over smoothing is, for example, if we add a lot of layer on our GNN, all the node representation are going to be more or less similar. And we want to avoid this, and some substructure of the graph accentuate the over-smoothing phenomenon. For example, just if we take a large click, the large click are going to accentuate the amplifying the message propagation, and we want also to avoid this. And a property of the Delaunay graph is the maximized click size is 3, so we are able to avoid this kind of substructure for mitigating over-smoothing and over-squashing.
There's one more question behind you, I think.
Oh.
I have a question for the author of the court judgment, predicting court judgment outcome in UK. Okay. I was curious on the goal annotation you built. I mean, you said to advise annotators, but can you provide some details on it? And especially for the criteria of choosing the annotator. I don't know if you can do.
Listen to the video.
I was curious on the criteria of the annotators. I mean, how many annotators you have employed for constructing the gold standards, and which criteria they follow for building it?
Sure. In the end, we had 14,500 places. We split it into more or less 500 places that the legal annotator manually annotated the outcomes. So the legal annotator was misread all the cases, and then having into consideration the claims, I annotated whether the outcome was claiming means and the losers partly means or other. For example, other would be a case in which, for example, the court decided to we held the proceedings and decided later, which means that there is no final decision. So we looked at all these cases. Me to do the gold standard, and then the other two legal experts they look at the same number of cases and predicted without only looking at the facts and the claims what would be the outcomes of these cases. Sorry, I think this is great. Can you understand the question? That's very well.
Thanks.
Okay, I think we're gonna move on to the next presentations. So we have two more. The next one is going to be online. Not much. Are the folks online ready to go?
So we haven't not shown the first paper, so the authors of the paper attributed question answering for precondition without law. Are next, are they online?
If you're online, just say something in the chat. Okay.
Yeah, as we said, we have no show, so.
Yeah, they won't be going.
Yeah, just share your screen and take it away.
Okay.
And maybe, we cannot hear you, so can we just your sound?
Can you hear me?
Yeah.
Yes, all set.
Great. And you can see me as well, I hope.
Yep, perfect.
Great. So thank you so much for being here. My name is Felicia. I'm here to present a paper called Attributed Question Answering for Preconditions in the Dutch Law. This paper is co-authored with Romy van Dries, Suzanne Verberne, and Maaike de Boer. We're all Dutch, so we're from either TNO, is a research institution, or Leiden University. I'm from University of Leiden. So let's dive into this paper. It's called Attributed Question Answering for preconditions in the Dutch law. So what is attributed question answering? Well, attributed question answering is very similar to question answering. You get an input question and the output is an answer. But besides an answer, you also get an attribution. So here's an example, very easy example, in which movies does some extra star, and you get the answer, some movies, and also an attribution. And the attribution can be a source of where you found these answers, like IMDb. But of course, we're working with legal data. So a more accurate example will be when can the Dutch court terminate the guardianship of a natural person? And then you can see an answer, which is just a fictive example answer, and you can see an attribution. So from which article in the Dutch law can this answer be found? So what we've done is our main contribution was to introduce a data set. And this data set contains 102 legal Q&A pairs with attributions. So to be clear, it's 102 questions that we created, 102 answers for these questions, so each has one, and each question answer pair has an attribution towards the Dutch law. These questions are focused on preconditions, and preconditions are defined to refer to the specific requirements, criteria, or circumstances that must be fulfilled before a specific action, event, decision, or outcome can legally occur or be finalized. Next to this Q&A set, we also created a knowledge corpus. So those attributions are pointing towards this knowledge corpus that we've created. And this knowledge corpus has been created by scraping publicly available laws. It contains about 20,000 plus articles from the Dutch law. And it's created by chunking with a hard cutoff of 150 words. With this data set, we've done some experiments. We've implemented a RAG framework. On the right, you can see a picture of what we've done. On the top, you see the question that the user asks, like, when can the court terminate guardianship of a natural person? Then the retriever component of the RAG system will retrieve the top K Dutch articles that are most relevant. And you can see the top K results in orange. Then it will all be pasted in a large prompt. So this prompt contains instructions for an LLM, the retrieved documents, and a question that was asked initially. It's going to be processed by an LLM, and then your output is an answer. You can also see, maybe it's a bit small, but in the answer, you can see that there's also a bit called use documents. So this way we can have an attribution. So we know which documents were used for this answer. We experimented with multiple types of retrievers, sparse, dense, hybrid, and we experimented with 4 open AI models, sorry, 2 open AI models and 2 open source models. So we experimented with these models, GPT 3.5 Turbo, GPT 4o, and 2 Dutch trained models, HiCuLR 7B and Llama. For our evaluation, we evaluated on 3 dimensions. We wanted to evaluate the fluency of the answer, the correctness of the answer, and the citation quality. For the fluency, we did this by using 2 different metrics, using the GEVAL framework. We checked for the fluency of the answer and the coherency. For the correctness of the answer, we checked for the consistency of the answer overall, and we checked for the relevance. Since we have a ground truth answer by a legal expert, we can just check the AI answer and the ground truth answer and check like how relevant is it actually, or how consistent is it. So those are the correctness dimensions, and we use regular metrics like Rouge-L, Meteor, citation, recall precision, hit rate to check the other metrics in these dimensions. Then we move on to the results. You can see the recall at 3, 5, 10, and the hit rate at 3, 5, and 10 for multiple types of retrievers. The best retriever here is the dense retriever called E5. We explored multiple types of retrievers, but this one turned out to be the best. And using this retriever, we did the experiment for all 102 Q&A pairs to see what the results will be. And you can see those 3 dimensions here for those 4 models. So the fluency, correctness, and citation quality for the OpenAI models and the open source models. The correctness and citation quality was best in the GPT models by OpenAI. The open source models had high fluency, but they lacked the ability to cite well, or they weren't as correct as the GPT models. The results here, the RAG system can generate really fluent and correct answers with an 83% hit rate score. So we were satisfied with the results. It can be better, of course. The answers are often highly coherent with the ground truth, but there is a large difference between the retrievers that you can use. So it's very important to know which kind of retriever you're using in your RAG system. There are, of course, some limitations here. The parameter size, there is a large difference because we don't know how large OpenAI 4o exactly is, the parameter size, but I assume it's way larger than 7 billion. So that is a limitation. Secondly, we have validated the answers with a domain expert, but we have not validated whether it's actually understandable to lay people. That's it. If you want to reach out, here are 2 email addresses, or check out our work at this link or in our paper. You can see our code and our data set. That's it for me.
Thank you. Okay. So
hello, everyone. My name is Dietrich Trautmann, and I'm from Thomson Reuters, and I'm going to present our research work on measuring the groundedness of legal Q&A systems. I would like to start first with the motivation. So more and more of our tools are using Gen AI in some capacity. For instance, Westlaw Precision, one of the biggest legal research tools, has this recently introduced AI-assisted research. So here we have this interface, and for instance, there is a box where users can then enter hopefully any legal questions that they might have, and then the system generates a particular response grounded in some legal databases. Another example is Thomson Reuters Co-Counsel, which is newly released version that again has a few legal skills available for you. For instance, a summarization skill. And here again, a user can provide a document and then the system performs, for instance, a summarization task. Like here we see that the user requests to create a summary from this document, and then the generated response is then also able to show the grounded part of where it was using the information from the provided document. So what is actually grounding, or how do we define this? So we say that AI responses must be traceable to the source documents, whether this being the legal databases or any user-provided document. There should be no claims beyond what sources actually say. And also the overall response should accurately reflect legal facts and the context overall. To this end, we created this new data set on legal groundedness classification, where the source were, like this was not user data, this was from internal development and testing sessions where we have realistic legal queries with corresponding responses. And another clever twist that we introduced here was to create these pairs of responses per user query. On one hand, we have the verified correct responses, so they were really verified by legal experts. And then we also created an intentionally corrupt version of this correct version, where we introduced subtle errors to the responses overall. So we did corresponding splits where we had this training, development, and testing data. And then we looked into different benchmarking methodologies, and after a research of what is available, we came to the conclusion of those three groups. So we have some similarity-based, where we compare responses directly with source texts. We have others that are based on NLI, a natural language check for entailment or contradiction of a generated response against the context. And then we used several prompting approaches. Some are kind of re-prompting the same LLM or another LLM to verify statements. Being not just a research project, but also thinking about how to get this into production, we then looked only at the performance on this task, but also in terms of latency, how long does it take to do this particular task? And this is kind of the result scatter plot that we have. We have the best performing model, this based on DeepEval, achieving 0.8 macro F1 score and a latency of 26 seconds on average. And then we have a kind of a close second, which is just based on GPT-4o with re-prompting, which was like basically a single inference call, resulting in a performance of 0.77 macro F1 and 2.2 seconds average latency per response. So kind of based on this information, you can choose your method based on your priority, whether it is performance. So you really want to have the best performing model, for instance, in an offline setting. But if it's really like a production setup, you want to have a quick verification, that you have maybe like will accept some performance degradation, but having a way faster response or classification. Additionally, we did even more analysis, but we identified several error types. In total, we concluded to look into 6 different error types. Most common error were factual inaccuracies, and you see the corresponding counts and other error types on the plot. And in our evaluation, then on the development set, the hardest to detect, although I have to say, like there were in total only 3 terminological errors and 2 were misclassified, so that's why it ranks so high. But in terms of absolute misclassification, factual inaccuracies were also one of the highest, hardest to detect. Furthermore, I would like to thank the whole team, especially also the leadership team in supporting us in this research work. Come to our poster number 150. And one final thing is, if you're interested in this kind of work, we are hiring across all possible roles. So feel free to ask me any question or our team's question. We're looking for research scientists and engineers. And yeah, have a nice lunch then. Thank you.
Other questions? Okay, great. Because the bridge is up as far as I heard, so there's a delay in the last. Always to know if the bridge is, I guess, yeah. Who was first, or shall we go on? You are closer.
Hi Derek, thanks for the great talk. I have a question related to one of the bullet point when you define grounding. So one of the criteria was that the generative AI test shouldn't say what more than the source say. So I read this as like trying to minimize false positive, right? Like not trying to like show potential argument that the model cannot strongly back it up. But I guess a potential problem with, I'm not saying that you over optimizing for false positive, but a well-known problem of like optimizing for false positive is you may potentially sacrifice on false negative. Like there might be potentially interesting and very creative kind of argument that the model could have suggested, and a well AI literate attorney can like, you know, make an adjustment on whether that creative argument is worth using. And if the grounding criteria is like too strict on minimizing for positive, it might sort of, you know, lose on that sort of more creativity for negative side. So do you have any take on that sort of how to balance between these two considerations?
Yeah, very good point. Like the details are in the paper on that, but all of the methods, they are then also optimized for a particular threshold. So that's exactly addressing what you are saying. Do you want to optimize for having fewer false positives or false negatives? Currently, what these results are, they show this balanced. But as I said, like we have the different methods all with the corresponding threshold that we then looked to balance. But as you said, like we could potentially optimize for one or the other. One consideration is then really that needs to be taken into account is then to like how much do you want to do the human verification. So currently, like we balance both of them, but kind of if you want to be more sure, then you can have like look through more conservative thresholds and then like let human SMEs review more for your case. But depends on your application. Currently, we did a balanced, so yeah.
Yeah, thanks for that. So my quick question would be I'm assuming that you have a sentence level answers and you have source documents accordingly. My question would be, what would be atomicity in that sentence? I mean, do you take a sentence, how much of a complex it is as a sentence, or do you also do some atomization to break into sub-facts or something so that you have much more precise grounding? The second question is on the source side. So is that assumption you have one source document or is multiple present? And do we also somehow handle conjunctional and disjunctional sources? As in, I might pick something from this, and put an or statement and write a big sentence. So do we do that partial mapping? So is the assumption of this particular task very much on one fact can be attributed only from one source, and it's like one-to-one mapping thing?
Yeah, also a really great point, and the details are of course in the paper. The different methods work on different levels. So for instance, some similarity approaches, we have really compared like for each sentence you wanted to find in the sources corresponding sentence that we can then consider grounded. Other approaches, like this reprompting, like this deep eval, there was an initial stage of extracting claims, which are sometimes just like partial sentences, and then again claims in the context, and then we tried to match them, and others worked on the whole response level that we wanted them to ground. So like there are different things that we considered. In the end, we aggregated all of the results on the whole response level to be comparable. So that was the first thing, and then the other one was, what was it about the context? Oh, I mean, like we were using, like this was based on a RAG, like a retriever. Here again, this data is from the legal research database from case text. These were, yeah, kind of snippets depending on the queries that were sent over the API. And what were you asking about the context?
As if you have like multiple snippets present, so let's say I have a sentence which I derive partially from each of them in a conjunction or disjunction manner. Do we also handle such type of things, or do we just restrict to one-to-one mapping kind of?
No, this was one-to-many kind of the. For instance, in this example, like, I mean, here in this particular summarization skill, we do this against one long document, but this is exactly what is happening. Like here, for instance, there are several statements that are attributed, for instance, like this in yellow, if you can see it, this is kind of like one source, and then there are like a few other citations from different parts of the document.
Any more questions? Cool.
Thanks for the presentation. We have seen many works before you that were talking about faithfulness. You mentioned groundedness in your work. They are somewhat correlated. What's your opinion on faithfulness? Is it related, and in what way with RAG? Question.
Yeah, this goes beyond what we did in this work. So we really looked into grounding, kind of like the direct grounding of, can we identify the corresponding matches from a response in the given context? Of course, kind of faithfulness ties then is more than grounding, I would say. Since like if you provide unfaithful context, we would kind of match against that. Like that was not the case here because we were not looking into that, but kind of that is what I can say on that point.
I have a question for Felicia. She's still online and can hear us.
Yep, still online.
Yeah, cool. Yeah. If I saw your results correctly, right, your retrieval results, you had the BM25, then the dense retrievers, and then the hybrid displayed. And I guess when you have the hybrid retrieval, the results were getting even worse than BM25. So I'm wondering if you have any insights on what happened there.
Yeah, that was an interesting result. We tested one hybrid retriever, and it was trained for only the English language. Meanwhile, the other retrievers that were scoring a better result were also trained for multilingual or for Dutch. So we think it's because of this training.
We do some work on hybrid retrieval, and we get some performance improvement there. So thanks.
Thank you.
Any last pressing questions? Cool.
Thanks. I guess this relates to kind of both presentations, but I was wondering if you guys have done any comparison on knowledge injection with retrieval versus knowledge injection with fine tuning. So did you do any like fine tuning on the knowledge documents to see like how that compared versus using retrieval? Either one of you, I guess.
I can maybe add that like we didn't do any part on the generation. So like this was kind of, we assumed whatever system is available, we kind of do this as a post generation step. But I definitely see in other experiments that oftentimes fine tuning on particular documents or a particular task has some benefits. That's what I can say on that.
From data curation perspective, I'm wondering, can we go into some granular level rather? I mean, currently I hope the attribution is at the sentence level. Just from a utility perspective, do you think people prefer more sentence level citations? Because if you have multiple sources, if it's a decision, when you have multiple, just utility perspective, is having a sentence level citation or attribution better, or a sub-sentence level is much more preferable or something? Or any thoughts on legal people, how they feel or what they want from it?
Yeah, I don't have any information about like what really user would prefer, especially the legal user. I think that's then also like a UX UI issue of like how much do you want to overload the interface with putting in the citations. Yeah, so. But it's definitely like an interesting point to maybe do some user studies on how granular do they really want to trace particular claims back.
Okay, let's hit it off, and I think more people will join on the way. So it's our extreme pleasure to introduce the keynote speaker of the workshop. As already said in the morning, the keynote talk is given every year by a lawyer. And the reason for that is to trigger us to think outside of the box, outside our models, our metrics, how we're going to evaluate things, and try to think, practically what we need from lawyers and get more input and try to, be a bit provocative. So for this year, we have the pleasure to have Professor Omri Ben-Shahar. He comes with a great CV since he got his bachelor NLLP from the Hebrew University, and also a PhD in economics and SJD from Harvard. He's a professor of law at the University of Chicago, but before that, he also has an impressive resume teaching at Tel Aviv University and also being a member of the Israel's Antitrust Court and also clerked at the Supreme Court of Israel. And before the University of Chicago, he was holding the chair, Kirkland and Ellis Professor of Law and Economics at the University of Michigan. He writes primarily in the fields of contract law and consumer protection. Today, his talk is it's titled Privacy Protection at What Cost? And I think he will challenge the usual paradigm of the regulation of digital economy, which is focusing around privacy. Yeah, without further ado, the floor is yours. We're looking forward.
Great, thank you very much. Do I need to talk to the microphone or can I speak again?
Yes.
Yeah. Okay. Okay. Yeah. Well, thank you for inviting me. It's nice to be with a different audience. I'm not a computer scientist. Also, it's nice to see so many young people. So to talk to people whose mind is not yet fully set in stone with respect to what we need to think about as the main problems that policy has to address. I am a law professor, but my training was in economics, so I think about issues more from a social science perspective. I've come to learn to study. My first kind of exposure to issues of privacy, data protection, came from contract law. Every time people interact with some kind of enter the digital economy into some kind of cybersphere, there is a contract. There are terms of service, there are cookie notices and things like this. There has been an ongoing, long-standing debate over 100 years in law, how to deal with all the fine print. Data privacy is by far not the most burning issue of, problematic fine print. But that's how I got into that. I'm now working on a book that's trying to develop the ideas that I'll talk about today, and hopefully when I leave time, I would love to get your reactions during the second half of that. So, okay, let me just give you a roadmap for my main argument. Data technologies, of course, provide great benefits, but also create risks and harms that policymakers and the law has to address and to guard against. Far and away, the most prominent paradigm of protection that circulates, especially in Europe, but also in the US, in places like California and in the Lina Khan's FTC, is data privacy. It is the focus on privacy, I think, is misguided. Not that there aren't problems of privacies, but I think that there are greater problems in society. You want to move that little? Yeah. It creates a mispriority in the sense that we are not paying attention to more important problems and to very important benefits. So data privacy is in a way, barks up the wrong tree. And in the course of doing so, creates all sorts of, it paralyzes also and disrupts technologies that have great social value. So as I said, so the benefits, it discounts benefits. Privacy laws restrict technologies in a way that I think is greatly underappreciated and massive. And secondly, it does not address problems that I call, not literally, but figuratively, data pollution. Okay, so let's talk about both the benefits and the pollution side separately. On the benefits of data technologies that data privacy laws restrict, namely the social cost of data privacy law. And I give you a few examples, but I'm developing a lot of examples. And here's a list of 3 things we can talk about today. So the first, and don't worry, it's not going to be boring, is about auto insurance. Just the word insurance can anesthetize an audience. But I'm going to talk about a telematics, a data technology that has been created by auto insurers about 20 years ago. It's now quite mainstream, and it is targeted very severely and I think tragically by data privacy laws. So what is this technology? These are embedded recording devices in cars, or now it can also be done through apps that measure how the car drives instantaneously. Everything that the car does, that the driver does, is measured. For example, speed, excessive speed, sharp brakes, sharp turns, cutting lanes, if the cars have cameras, distractions, texting, things that insurers know based on the vast historical data are correlated with, in fact, cause accidents. Texting is not just correlated with accident. It causes. And so they know that when you do it. And they can charge premiums. The models, machine learning models are now used, although before they could have done this fairly well even without AI, that predict the risk of accident in a personalized way and based on how people drive, and create a safety score. And that safety score changes as people change the way they drive. And the premiums, every month you get a different insurance premium based on the safety score. Right now, there's about 25% of the auto insurance market in the US is people enroll in this. You don't get put into it. You don't kind of get opted in without knowing. Usually insurers, in part because you need to, for some insurers, you need to download an app and enroll in it, and others you have to install a device in the car. That's how initially it was introduced. This is what it looks like on your app. You can open your app, check your safety score, and as you can see, there are all sorts of factors that tell you why you're scored the way you're scored. Forward collision warnings. How many were you warned that you're getting too close and too fast? Hard braking, aggressive turning, unsafe following, per trip, per day, per driver. If you create these capabilities, and at the end of the month, you get an email and says, based on your this month's score, this is your premium. This is another company. In fact, this is from Geico. They don't use devices. They just use an app. Download a separate app than the general Geico app, and it scores you on a thing. You see things very similar. It turns out that it has. You'll see that we're going to go to data privacy in just a second, but it has pretty significant safety effects, which are theoretically predicted. It's interesting to see the magnitude of them. But first of all, if people are rewarded by premium discounts when they drive safer, when they have higher scores, they will have an added incentive to drive safer. Also, drivers receive real-time alerts, and you saw these kind of dashboards that tell them what is expected of them. So now they know what not to do. In the 1960s, there was a very, very important finding in social psychology, one of the most robust findings ever in social psychology. It was found in a survey in Sweden that 90% of drivers think that they are better than average. That 90% number turned out to be enormously robust because on almost everything that people do, 90% of the people think that they're better than average. And it turns out that in auto, it's a very sticky, very resistant number. Even if people get into accidents, those that get into the most accidents, you survey only these people. 90% think that they are better than average. Even if they were adjudged by court to be negligent, at fault, 90% think that you can't get rid of that 90% number. Well, maybe people need coaching. So here's, at least in theory, this will show them what the algorithm thinks they need to do. Now, of course, people might say that stupid algorithm, as my son says, when every time he returns the car at my 20-year-old and says, that stupid algorithm, you know, they don't understand. But there is resistance there too, but at least there's hope. Finally, there is this sense of, you know, everything is being recorded. When people are being watched, that triggers, again, psychologically, a different type of evaluation of cognitive mechanisms, slower thinking rather than impulsive. And I mean, check yourself. If you know that there's a camera in the room, you don't even know if there's somebody there. It already changes the way people behave. So for these reasons, we have hope that maybe people will drive safer. What is striking is how much safer. And this is the evidence. There have been studies done with large data that comes from various insurance companies and also experimental studies. I've read the whole literature, and it roughly equates to 30% reduction in fatal accidents. Take a second to appreciate that. There has never been a safety technology in highways that reached that effect, not even close. All other safety technologies are costly to install. They require, hardware. They require better highways. This is nothing. This is data. So just an algorithm. 30% reduction. When the first company installed it, Progressive, the data, these things are published at the top-tiered econ journals, heavily refereed. This is not bogus saying. I'll put the different observations here, but they get at this number from different directions. The reductions occur, maybe some studies measure speeding, others hard braking, others the safety score itself, how it improves. What we see is that within the first month of driving, by the end of the first month, people change the way they drive. Here is the improvement within 30 days. You get to the curve flattens. Safety scores reach the max. The number of hard brakes. Hard brakes is maybe the most important indicator of risk because it means that you don't leave a lot of time for unexpected, unforeseeable things to happen. That's how accidents occur. So that's one benefit. Not done. There's another benefit. The other benefit is fairness. First of all, lower premiums. So that's not entirely distributive fairness, but isn't it nice to pay less for insurance? Because why do you pay less? Because you drive safer. That's the main reason. But also, and this is critical in auto insurance, I don't know how much this has been, in the communities that I work in, this is always brought, auto insurance is brought in as an example for a very unfair and non-progressive way of rating people, of charging people, because insurers take into account what? Credit history, home ownership, education, income, zip code, multi-line insurance. Do you also insure a home and a second car? All of these provide discounts to whom? To the affluent. A person, there are so many ways to show this, but basically, if you are at a low FICO score, low credit score, all else equal, you pay more than double than the same person that has the highest base score. All that is gone. Nothing, no group rating, no social demographic rating, no need for correlations. We have the factors, the causal factors, and everything is personalized. And so, the famous thing about auto insurance, that men pay more than women, young pay more than young women, because on average, they drive more recklessly when they're young, gone. Not all men, it's actually just a small group of young men that are like this, but insurers can't tell. So all men pay more. All that is gone. Okay, why am I telling you all this fairy tale? Because California prohibits it. You can't enroll in California. Why? Data privacy. California insurance commissioner, very, in California, because of earthquakes and other things, insurance is a very important thing in politics. Insurance commissioner, who will one day probably very possibly be their governor. We won't bend on protecting consumer data, privacy, and fair rates. For kind of a passing moment, when this data came out, that commissioner thought maybe we should reevaluate our long-standing prohibition against using telematics in auto insurance. But that fleeting thought passed, and the data consumer and data privacy advocacy may persuaded him differently. I'll just mention, when I was writing all this, everything you heard has no trace in the literature. There are symposia devoted to the horrors of telematics auto insurance by sociologists, law professors, and dozens and dozens and dozens of articles, including a very good book that talks about not a word mentioned on the things that I told you. Privacy, data privacy, or some ambiguous conception of data privacy is a trump card. It's like overrides everything. Notice, this is an opt-in. This is not a click, I agree, you don't notice cookie, can't reject it, okay, I'll take it. This is an affirmative opt-in with putting your credit card and installing a device and downloading an app and all that. This is something that people, if data privacy is a way to protect one's autonomy, you would think the privacy advocacy would be open to it. But if you thought so, you're wrong. Some states, think about that. Some states like New York allow it, but they have all sorts of restrictions. For example, you can't use the data to increase premiums, only to reduce. Why? To protect consumers. Who are you protecting if bad drivers don't pay the price they need to pay, namely others have to cross-subsidize them? Also, New York doesn't allow to use data about distracted driving. They single out that piece, maybe the most dangerous thing that people can do, and saying that you cannot rate. Why? Because that is hardcore privacy. It's to know the device is the locus where you have to protect people's private spheres. So they touch their device, shouldn't know that you should protect their privacy. So we see that DNA of data privacy interfering with this regulation. So, just to think about it, to summarize that example, California has 4,000 annual accident fatalities. If it were to mandate this, perish that thought, but if it were to mandate it, they could save the lives of 1,200 people every year. We now have this technology for almost 20 years, 25,000 lives. Data privacy on one side of the scale, 25,000 statistical lives on the other. And that's only in California. Think about what we can get in other places as well. Okay, so that was one. Number two, facial recognition. Okay, now I'm going on a limb. I know that this is the biggest no-no in the data privacy world. Facial recognition technology that is trained on billions of images to be able to identify who you are based on a photo. You know about that, much more. You also might know, and we'll talk about it, how much it is regarded as the highest risk to privacy. And I understand why. Unlike data tracking of how people drive, this does go to core privacy concerns. And it might be important to restrict and limit it. Here, I don't have the conviction that this technology must be implemented urgently, as I had with the other one. But I do think that we have to think about the upside as well. And I want to mention them because they're never mentioned as well. There are the discussions on that when the AI Act passed in Europe, when California and other places are putting restrictions on, and when the discussion of reducing the use of facial recognition in law enforcement never takes into account the upsides, entirely denies it. So And in law enforcement, there are significant benefits, and the benefits are concentrated in enforcement against human trafficking, including sex trafficking. This is just a nice name for slavery, human and sex slavery. One of the biggest criminal enterprises in the history of society, presently up to 28 million worldwide, are in forced labor, many of them subject to sex trafficking, 20% children. Incredibly hard to enforce against, because once they are taken, they don't see the light of day. How do you rescue them? There's very little that police can do, and there are opportunities to identify when they pass borders early on, or when they are, sexual encounters are posted online. The software is developed by private companies, some non-profit, some notoriously for-profit, and the data that I'm giving you here does not come from social science journals, but from media reports. But when you cross the various data that comes from especially from the law enforcement, various channels of law enforcement, you get a sense of the magnitude that we're talking about. So Spotlight is a nonprofit that started, I think, by Demi Moore. Uses Amazon software, images software. Reported that it had been used by law enforcement on almost 40,000 cases in North America, in which investigators found more than 9,000 children, over 10,000 traffickers. They have separate tools to identify scenarios of trafficking on images in social media. Similar findings with similar magnitude with annual campaigns that use this technology in India. There's been a letter by 21 state attorney generals to Congress asking that, suggesting in the letter, the state attorney general saying that it was used by law enforcement to identify more than 18,000 trafficking victims and more than 6,000 traffickers, reducing investigative time by up to 65%. A lot of testimonials by investigators of how they were able to use this and what a difference it makes. Privacy laws, again, prohibit this. The EU AI Act says that real-time remote biometric identification is the one category that is at the highest, unacceptable risk. It's not high risk, it's the highest, and banned. A New York Times reporter by the name of Kashmir Hill has made it a kind of a crusade to expose the horrors of that technology, and you see the kind of way it is thought about. There is no benefit that could justify the use of this technology, even selective use of this technology. And when the EU data protection watchdog was told that the Interpol was using this technology in sex trafficking, he said, wait, but there is data privacy of the trafficked people. Migrants, vulnerable people. We have to protect their privacy. Part of the problem is that data privacy has reached the highest echelon of private rights. It was something that when it was invented 100 years ago by American jurists, the notion of privacy right didn't exist historically. It was thought to be a means to support other things. Now it is at the ultimate, it doesn't need its own right. It's a fundamental right, in some contexts, fundamental human right. And therefore, it is as high as the right not to be tortured. Don't need to justify it. And you also don't say, oh, okay, sometimes it's okay to torture people. Right? It's an absolute ban. So here's where we are. And constantly you get reports about how, the attempts to enforce by European countries and by some states and cities in the US against the use of these technologies. Just their presence is already fined. There are issues here that have to be recognized that do not exist in the auto insurance context. So, for example, in the auto insurance context, we said that the technology favors poor people and racial minorities. There is a concern that facial recognition is adverse to, especially to racial minorities, and there have been reports of cases, several cases, but very prominent, in which, and it always happened to Black men, they were falsely identified and arrested for a crime they didn't do. Technology was not as accurate and was labeled by some as, the algorithm was labeled as racist. Of course, the problem is not, let's start by recognizing that racial inequity is so deep in law enforcement, in criminal law enforcement, even without algorithms. In fact, it's much worse without algorithms. In many other contexts, like risk prediction algorithms, reduce the biases that police and judge have against Black men. But the algorithm had in early years also some greater cases of reported cases of error, something that you can equate to the psychological phenomenon known as other race effect. So in the US, the algorithm is better at identifying Caucasians and wasn't as accurate in identifying Asians and Black people. In China, the algorithm is better at identifying Asian images and not as good as Caucasian. When you have less images to train the algorithm, you get that effect. So it is not, it's something that has to do with the quantities. And the problem is that data minimization laws, which is a set of laws that says that when you have data, there are only different ways in which you can use it, tag it. There are things you don't want to know about it. For example, you cannot tag the data by race. As a result, it operates less accurately for racial minorities. As a result, you cannot do audits on the data and on the results because you don't know the race or gender or other protected characteristics. So the motivation is good, but the result, it backfires. Okay. Just so that you know, the problem has largely been solved of disparate accuracy. It was a problem that had to do with not enough data to train, but by now there is enough. And in the big data privacy manifesto written by the same New York Times reporter, Kashmir Hill, on the issue, she says in the end, and kind of sheepishly, the book is mostly about racial inequity. That people, the data privacy advocates, are saying, you know, shoot, that problem has been solved. Now we don't have a good argument against it, where the main concern is not racial, not discrimination, but data privacy. So something is going on here. So that's the big number one message of my work: data protection at what cost. And I can talk more. We don't have time. I expected I won't have time. So I said, should we talk? And the answer is no, about medical privacy. And in my study, I looked at the implementation of the uses or the limits of privacy laws put on electronic health records. That's something that by now your generation doesn't remember the days when your health records were on paper, but when these things were digitized, initially states and then federal law said, no, you can't do that. Privacy. If it's digitized, more people can see it. We can't really protect it. Studies are done mostly by MIT economist Catherine Tucker, demonstrate how states in which this happened, the adverse medical results in treatment, there were adverse medical results in treatment. She focused on neonatal deaths, babies, preemies that need where data and preparation at these high-risk pregnancies is really critical. And estimates the value, the lives lost of babies per year in the thousands. in places where there was resistance to electronic health records. Presently, the main resistance occurs in medical research, in biomedical research, where you have a lot of data in hospitals, and researchers want to do secondary reviews of the charts, of the medical charts. Give us all these charts and we will cross it with all sorts of other things, and we will begin to see patterns that in small studies you don't see. There is enormous benefit to that, and impossible to do. Why? Because data privacy laws, a law called HIPAA, federal law, requires that every individual whose information is in these charts will provide fresh consent, written consent. Call them and then send, and they have to run. They don't provide that. And if those are provide, what you get the people, the young people that don't care provide consents, and the older and sicker people don't, and you have misrepresentation in the data, and it's worthless. Again, this is the cheapest way to do medical research now. We don't need big labs. Just look at the data and see the fine and cross it with social demographic things, and you can overcome all sorts of disparities in the provision of healthcare to minorities, and especially in the US to racial minorities. Can't do that. It's so heavily restricted by that. So I said, I'm not going to talk about this, but you see, I couldn't stop myself. Sorry. I'd like to have time to discuss for discussion, and maybe I'll take 2 or 3 more minutes. That's only half the story. The other half of the story is data privacy, as I suggested until now, restricts important benefits that we can have in society. Traffic casualties, human trafficking, medical progress. It also, but it does something good, right? It protects privacy interests. Well, what it really needs to protect is not privacy interests. What we have, I call it the problem is data pollution. That kind of an issue that occurred to me in 2016, immediately after the first Trump victory, when there was a concern that, you remember Cambridge Analytica and fake news, and it was called a privacy violation. The Senate held hearings about data privacy. And I thought to myself, what's privacy about it? The harm is of the most public of all things, our election. If you go to the voters that voted for Brexit and Trump and say to them, we want to protect you from your privacy violation, they will take out a gun and say, get out of here, right? They don't feel that their privacy was harmed. It was public things that were polluted. Or take another example from around that time, I think 2017. Strava is a social network for athletes. They bike, they run, they do whatever it is that athletes do, and then they post the heat map on their app, and you can see the map of a region where they are running. And there are more people doing exercise. It's kind of aggregated. So why am I putting Kabul here? Because that was the kind of a scandal. American soldiers are the ones that are running, and now you can see where they are concentrated. Or there was another examples in Niger, in Africa. And again, Congress has hearings about data privacy. What data privacy? Who's? The athletes? They're posting it. They're splashing it to show the world. They don't want to hide it. What is an assault on our privacy, a privacy nightmare? Say all the media and everybody just kind of like parrots, calls everything that has to do with data, they call it privacy. The problem there was national security. Is there anything more public? Maybe putting others at risk, what economists call externalities. You see, basically, I want to stop here, because, so I want to summarize how I think about data's public harms. Yeah, okay, but maybe I don't want to just hear myself. People talk about the privacy paradox, right? Individuals say that they care about privacy, but behave as if they're not. There's a very interesting parallel to understand it. That's the greenhouse gas pollution paradox. People say that they care about climate and about pollution, but they buy polluting cars and they engage in polluting activity. It's very, there is divergence between what people say they feel and how they behave. But of course there is, because what they are saying in the greenhouse gas context is we care about something social. It's not that we care that if we behave in a polluting way, we will breathe polluting air and will get polluting cancer. They're saying that our society is polluted. And that's what they are saying about data. We are worried about this brand new world. It's a little creepy what's going on. I don't care about myself, they say. And they'll give, after they say this, and MIT students have been surveyed, they all say, yeah, we care about it. And then Catherine Tucker offers them a slice of pizza for all the data in their phones, and they give it. So it's the public harm. It's not the private harm. It's not data privacy, how it affects my sphere and the things that privacy is about, the most intimate things. It's how these things play out in discrimination, in polarization, in national interest. That's why we're shutting down TikTok, right? Congress wants to do that. It's not because of the, it's because it's a Chinese government. They know things about us. It's national. Data localization, they call it. And so concentration, market power, crushing, reduced innovation, whatever problem you want to identify, it's all public. Because we use the tools of data privacy, we're not doing much about them. Data privacy is about giving you data self-determination. We can give you greenhouse gas pollution self-determination. You'll buy, SUVs. It's not about self-determination. It's about restrictions that we have to borrow the restriction. And that's why I'm using the greenhouse gas analogy. We already know how to deal with it. Until the 1970s, all pollution was addressed. There was no environmental law. It didn't exist as a field. The only way is to sue for your injury, your cancer. That never worked because you can't prove who caused, which emission caused your disease. It's hard to value. And so we had to invent a public law. Public law protects public interests, which is called environmental law, and to set up an environmental, an EPA, Environmental Protection Agency. This is exactly what I think we need for data, to think about it in terms of pollution and to have a data protection agencies that uses similar tools. You can think about data tax, carbon tax. That's what Europe does in environmental protection. You can think about restrictions on particularly toxic data. It's a little harder to define compared to toxic chemicals. You can think about liability for exposure. You can think about data spills. All these security breaches that occur all the time. It's also not a private harm. If your data is, most people, in the US at least, people are largely insured against credit card fraud and identity theft. There is some hassle. It's not a disaster. It's a problem for society because we have to have a big insurance scheme to cover these kind of losses. But what does data privacy do? Data protection does? Gives you notices so you can do all sorts of shields and all that. Who even pays attention to that? And why? So if you think about it as a data spill, like oil spill, you can begin to think about how to create a liability scheme. What matters is not that people will be compensated, because they don't have harm. What matters is that those data collectors will pay so that they will secure it better or do whatever it is that we think needs to be done. Okay, so that's my thesis. It's all going, I'm finishing a book manuscript called Why Fear Data, and it'll probably be published in a year. So I hope it kind of whets your appetite to think about things in the policy issues in this framework, a more economic framework that looks at public interests, both harms and benefits. And I'd love to hear some reactions and pushbacks. And, please.
Oh, yeah, but which one?
I have a question. In principle, data privacy is fine that you separate individually in separate places. But when you aggregate data, you create patterns. And in principle, there's kind of this example of trouble.
Yeah.
Even if, let's say, there's a person who is visiting some places specific on this heat map, just a few points. And in principle, you can predict this, that this is the person via one to target. So by data, you can create patterns. And you say that it's not about privacy. But when you get the person, the few, let's say, private points, you can put to match that pattern. And in principle, you kind of expand identity or recognition of that, and then you can target. So, and this is, I see here, it's even when you say that it's not about private data, but it is, because you can, from simple few points, you can target that person in different points.
Yes. And I'm willing to accept this as an important, look, I don't want to deny that part of what can happen in the context of the use of data technology and predictive analytics is to target individuals. That's the main concern with facial recognition. And I started by saying, I recognize that this is problematic, that people can put their phone to see you and then know everything about you. The books and the articles that are now richly proliferate all talk about the horrors that can happen, the hypotheticals, as in your case. They could happen. I think that what's important is to not let that particular possibility be the end of the conversation about what we should do with the data. It should be the beginning. Environmental protection take the production of some of the most dangerous, toxic chemicals. We don't shut it down to zero. We don't ban them as unacceptable risk. We say we have to find ways to limit the exposure, the uses, to allow for the benefits to be produced and to try to minimize the downsides. In facial recognition, I think it's probably great if law enforcement agencies that do human trafficking enforcement will have access to this. And yet it's not yet clear that we are ready as a society for Amazon or Google to incorporate it into the everyday use of everyone. That is the creepy factor. And I see that the creep is very personal. So I think we have to think about the two in the benefits and the downsides at the same time.
Question?
Thank you for the talk. It was really interesting. It expanded my mind a bit to think about this. I also liked the analogy of using environmental pollution to data pollution, but then also that sparked my own generation's personal thoughts, where we feel like Environmental Act and a lot of these guardrails weren't in place, and it's like rather than a proactive approach to environmental pollution, it's a reactive approach where the consequences happen and then people go out there and we as a generation suffer, but we don't get any reparations in return. So I feel like the same thing might play out with data. Like right now there are guardrails that prevent this from happening, but I feel like the same thing would happen where the pollution would happen, we would do the suffering, and then later there would be consequences for the organizations or the corporations that do this, but then we don't get anything in return. I wanted to hear
Unfortunately, I agree that the political process, let's say in the next 4 years, the EPA in the US will not make things much better to the extent that it ever has, and that it did only incrementally and definitely not satisfactory. But I guess my point is pragmatic. It's your only hope. Data privacy rights, fundamental right to data self-determination, a universal right for all that rhetorical gibberish that is produced in Europe gives you the cookie consents, the cookie notices, And people think of data privacy as an annoyance. They have privacy fatigue. It can't rely on individuals to be the agents that will decide, you know what, I am quitting Google, I'm going to DuckDuckGo. It's not, people will not do that. What we need is to maybe find ways to, as hard as it is and unsatisfactory as it might be, to use the tools that have the potential to work, not those that just make the intelligentsia feel good about.
Okay, I think Catalina is online. Maybe we can see her as well.
Hi, Omri. Thank you so very much for the picture. It's been such a pleasure to listen to you, especially the part with the gibberish coming from the European Union. I listened to references to the AI Act.
I'm so sorry. I forgot that you're listening.
I absolutely completely agree. And I have a question, but before that, I also want to give you an example, which I think could be very relevant for your book. It comes from the Netherlands, and I can elaborate on it separately, but it's basically a little bit of a privacy paradox in the context of gambling addiction, where gambling addicts can actually just register themselves in a specific registry, and then they are supposed to not be targeted and not be involved in the gambling industry anymore. But because of privacy regulation, the very strong privacy regulation in the European Union and also in the Netherlands, there is a loophole where they can still receive spam from these services that are trying to get away from. And even the lawmakers have acknowledged, okay, we actually have a little bit of a problem with this paradox, because on the one hand, we want to preserve the privacy of these gambling addicts, but on the other hand, we're still putting them in harm's way, because they will still receive the spam, and the spam is going to be basically, oh, here's 50 euros, and then you can go in and restart your gambling career with this. So this is an example, perhaps I'm happy to elaborate on it. But my question is more also, given your background in law and economics, and the fact that if we're speaking about this cost and benefit analysis of regulation, particularly data protection regulation, particularly also, for instance, the AI Act, one would argue that, okay, we do some impact assessments, we see what is the price that society can pay if we have to pass this type of regulation, and what is the price that we have to pay if we don't pass this regulation. In the context of the AI Act, what we have noticed, and together with the colleagues from this workshop, we also wrote about it for proceedings from this conference last year, there has been so much hype and so much normativity when it comes to the goals that such regulation should actually have as a result. So I'm wondering, how do you feel about this transition from a very economic impact assessment and looking, okay, statistically, which populations in society can be better off with this regulation, to this more theoretical protection of, maybe ideals or, very theoretical goals of what should be better in society, which is, at the end of the day, very subjective, and which, in the context of the AI Act, left the door open for a lot of interpretations from a lot of different interest groups that actually led to regulatory capture. So I would be very curious to hear your thoughts on that. And thank you once more for your wonderful lecture.
Thank you, Catalina. And I don't know if to say that I love or hate the example on the addictions, but it is very illuminating. So I think, unfortunately, I like it as another illustration. I have to think more. I don't want to just kind of speak off the cuff about the mechanics of how to regulate and how much to leave things ambiguous so that they can be worked out later. I'm a little bit worried that you have young technologies like, and AI is in its infancy, and Europe is rushing to classify and to use the strongest of all regulations here, not just, disclosures, consents, like they did with the GDPR, but outright bans so quickly. Now, I realize that sometimes that's the only opportunity to do it before things it might be too late. So I'm not a political scientist, and the entire conversation we had here today was basically on principles for rational, logical regulation. Once you wash it all through the political process, there are so many other complications. I was happy to see when I was reading about facial recognition that notwithstanding the ban on facial recognition in Europe, notwithstanding what the privacy watchdog says and the data advocacy echo chamber talks about, they are creating all sorts of opportunities for law enforcement to use it in some contexts. Maybe not enough, but there's a sense that when something is particularly good and useful, maybe in that context, it would surface as more permissible, subject to very important guardrails. It's also encouraging that US Congress and the various agencies that it directs is focusing in the context of facial recognition in law enforcement, is not focusing on bans, but focusing on guardrails. Namely, should use it, but here are ways to systemize the safeguards so that it will not be used in manners that are problematic.
Cool. I have one question, because also it's also a question in the chat. I'll phrase it. So many of the people in the room, they work with large language models like ChatGPT and all their variants. They live in them, including me as well. And I think that there one of the big concerns is that we have all these big models trained by all the big tech, and we don't know what data have been going there. I think there are already concerns about violations of, I'll say, infringements related to intellectual property, but I can also see cases as well related to privacy. So I'm wondering if you have any thoughts about it, and if maybe to turn your thesis around in the sense that could that save us in the sense that maybe our data, maybe privacy in this case, saves us because our data will not end up in these LLMs, I don't know, doing whatever we are doing. So I'm wondering if you have any thoughts.
I don't know a lot about how the sausage is made there. And I'm sure I know many people who were never big data privacy kind of diehard believers, and then saw how Google works and how, oh my God, this that. So I don't know the input side. I am more, kind of concerned in how we think about the output side and how notions of personalization, customization trigger instant opposition, and sometimes for good reasons, like disparate impact on minorities. But it's always cabined in this idea of privacy, which then means that ultimately, here's a prescription I'm willing to stand behind. Ultimately, in the US, if it's privacy, it will be solved by a notice. Just give you disclosure so that you can decide. And that does nothing.
It's a sort of conceptual question. So I think a lot of sort of raw privacy arguments are hypothetical and sort of relate to a common type of argument that you typically found in a lot of legal debates, like slippery slope kind of argument where scenario A, scenario 1 is acceptable, scenario 10 more likely, and scenario 10 is unacceptable. And I guess in your sort of driver tracking example, let's say California allowing that technology to be used will be scenario 1, totally acceptable, and people want to drive more safely and so on. But I guess a slippery slope kind of argument will be it might lead to some future scenario where, let's say, the insurance company attract enough subscribers to that online tracking technology, like 90% of their clients, and then they have sort of enough power to sort of nudge the remaining 10% of the clients to not really voluntarily subscribe and to subscribe anyway, maybe because of they raise the premium to like 10 times the premium before. So what kind of like guardrails would you think should be appropriate for either that specific driver tracking use case or more broadly to sort of counter that slippery slope argument to assess the privacy protection?
Yeah, great question. Thank you. I think one way to think about it is to give it a name, the slippery slope. And I think oftentimes it's called the precautionary principle. Here's how it goes. Something really bad can happen. We don't know that it necessarily will happen. In fact, theoretically, there are reasons to think that it's not very likely. It has never happened. But given the possibility that it might, every possible, no matter how costly, restriction would be justified. That's a very European approach to regulation. The US is more cost-benefit analysis, and I think that in many contexts, it is justified when you can think about a catastrophic thing that is very small probability, but you still need to, better safe than sorry. The problem is for this particular version of the precautionary principle is that how do you adapt it once you begin to get some information that things are not so bad? So the example, you return to the example of tracking of drivers. We now have, it's been around for 20 years. People that subscribe are super happy about it. Bad drivers, people from all, it's not just that the good drivers subscribe and get good ratings. Bad drivers subscribe and get good ratings. People, you might worry about poor people, about racial minorities. They be suspicious because they'll screw us here too, like they always screw us. And look, all of a sudden, it's a big equalizer. So that gives me pause about the strict application of the precautionary principle. Now, even if I were still a big, precautionary person, I would say, okay, there is this 10% in the example that they might be, their hands will be tied and they'll have to do it against their will. By the way, auto insurance is already compulsory. Nobody likes it. So they're not going to like it a little bit, more intensely. But 12,000 lives every year in the US. Is that worth sacrificing so that these people will not feel so uncomfortable and they want to continue to be non-tracked and all that? I don't want to answer this question, but I think you see by asking it, you can begin to see how I think about the answer.
So I want to ask about, is it possible to use state laws or like state government documents to guide AI or without concerning about the privacy laws related to like creation or use of these data?
Yeah, I need you to be a little more specific, like guiding.
Currently, like if you consider LLMs, so LLMs can do some memorization kind of stuff, and then it can, in some of the cases, it can like violate privacy laws sometimes. So can't we use like state laws or like state survey data that can actually guide AI to not, so the guardrails for the AI basically can be developed from using state laws and survey data for everyone?
I think in principle, I think the answer is yes. And there are ways in which state laws can restrict the type of data that can be used to train algorithms, the type of data that algorithms will see when they do the screening. I think that this is incredibly useful, for example, when we think about, I'll give one more example I didn't talk about today, risk predictions in criminal law. You have a suspect. The question is whether to grant them bail, release before trial, or parole, the end of their service, or how long the sentence. And oftentimes the big question for the courts is how dangerous are they? How likely are they to reoffend? And the judges presently look at them in the eye and decide. They get some reports from social services and stuff like this, but it's done in a very holistic way. The colleagues at the University of Chicago trained an algorithm, a machine learning algorithm based on 1 million cases in the past, in which they are able to improve these predictions so that you can release 40% more people than judges do without getting more reoffending. Or you can release the same number that judges do, but choose the right people and get much less reoffending. And the nice thing is also that they show that it performs enormously well on maybe the most important thing in American criminal law, which is racial justice, social justice. Namely, it releases far more Black defendants than judges do. So you get less discrimination, less crime, and less jail. Win, win, win. And the way to train these algorithms in a way that, people are concerned about all sorts of racial effects is to allow the training algorithm to know the race, but not the screening algorithm. And so in this kind of context, legal restrictions on what pieces of the data, what tags in the data need to be removed or mandated to be included could do a lot of good, something that you won't see the industry do on its own. So I'm just giving this as an anecdotal example on how intervention can deal with issues. Again, my main point, not privacy. Discrimination is not a privacy issue. And that's, I think, should be, at least in the US, a central goal.
Okay, we are out of time, but yeah, let's thank our speaker. Let's give a big applause.
Thank you.
Thank you so much. I think it's been great. We will all remember also your nice references to the EU legislator approach. So thank you so much. It's been really thought-provoking. So thank you for this.
Thank you for inviting me, and stay in touch.
Cool. So we have no break, but we're going to move in the next half an hour session. The structure here is that Ben, who sets up now, will present the shared task and how it was created, how it was implemented, and yeah, the results, obviously. And then I think 2 teams are here to present, and that will take us to the coffee break. Probably will need a bit more time for the coffee break, but I hope that you can all make it without coffee for the next 25 or 30 minutes.
Hi everyone. Thank you for staying for the last day of the conference, and thank you again, Professor Ben-Shahar. It was fascinating talk, and I think I don't know who planned this schedule, but I think this is a very interesting transition what we're going to present right now. So I'm going to talk about LegalLens shared task, and my name is Ben Hajjaj. I'm from Dero AI, and this is the first ever legal violation detection shared task. This is a collaborative work with a group of amazing people, but also, as the name entails, with a wider community of researchers. So let's start. I'm going to cover, let's move a slide. Yeah, motivation. I'm going to talk what is LegalLens and, of course, the shared task. So 20 million, that's the number of civil lawsuits that were filed in the US in 2023. That is a massive number, but is not the whole story. Why? Because if you look at another, I have a problem here with, yeah. If you look at a number of reported legal issues and the same year, we can see that it is about 60 million of them. So 60 million households report on at least one civil legal issue. So only 1/3 of them going to court. But that again, not the whole story. This is just what people report. what people know that happened to them, what people aware of. And what we're trying to discover is, if we look at it as an iceberg, we want to not just look on what is above the surface, but also what is beneath the surface. We want to tell the stories that nobody knows about. We want to find these hidden legal violations and bring them to justice, bring them to light. That's exactly what we're trying to do in this work. But how we discover some of them are digital, and that these traces is exactly what we're trying to track. And we're trying to track those traces, and we assume that they will lead us to understand the bigger story, the legal violation. And our goal is basically to set standards for the NLP community for legal violation detection, meaning publish resources, data sets, and frameworks for this important task. And that's exactly what we did with LegalLens. Our approach is basically two-step approach. First is finding the trace, finding this digital trace that we want to track down. And the second task is associating this digital trace with some legal ground. For instance, legislation or law that can support the findings of the digital trace. Something like what would lawyer would do when someone knock on their door with a story, right? So that's exactly our approach here. And let's see the setups for the task. The first task, as I said, it's finding the trace. So we use here what we call LegalLens NER, which is we introduce here 4 new entities: the law, violation, violated by, and violated on. And we use about 1,000 examples that we manually annotated and created. And we use standard weighted F1 score for evaluation. Let's see a simple example, how it looks like. What we can see here is a summary of an article about some PPP regulation that a bank was poorly violated. And this example, you can see for the 4 entities highlighted. So that is a very simple example, a very explicit example. Let's take a look on more implicit, more realistic use case. Here you can see a tweet about a man complaining about his health company. And what we can see here is that the violation is highlighted by using my health info without saying my say-so, and we mask here the company name just for compliance thing, but it's also highlighted here. And to me and other patients, it's the violated on. So that is more realistic, what we assume to find online, and that's exactly what we want to track down using the first method. The second task, as I said, is associating with legal ground. What we want to do here is to give an hypothesis, which is exactly the same digital trace that we found in the first task. We want and the premise, which is some legal ground. We used summary of precedents, summary of legal cases, and we want to figure out what is the relationship between the premise and the hypothesis in this task. And we used manually annotated and created 400 examples with 4 different legal domains: privacy, law, securities, and consumer protection. And we use here the macro F1 score for evaluation. And let's see a simple example of that. What we can see here is a hypothesis, a digital trace about a company that is more lying about their product capabilities. It's highlighted in the yellow above. And the premise is a verdict or summary of a case verdict by a judge that talks about a fine or to a company that violated some similar scenario. So in that case, what we want to achieve is the entailment between the two. That will strengthen our knowledge about the digital trace that we found. That's exactly what we're trying to achieve in this second task. So we build the data set, we build the methods, we create some benchmarks, we publish it. It's already happened in EACL. This amazing group of people were part of that. And we wanted more. We understand that this task is super important. And we want to collaborate with much larger community, or even I would say create the community that's dealing with legal violations detection. So that's exactly why we did the shared task. And we're throughout the summer, from June to August, and we were happy to host 87 participants from 15 countries, sorry, and 38 teams around the globe. It was fascinating to see all the contribution. They, of course, outperformed the baseline models that we presented before with that amount of people. That would probably what will happen. But we're also very happy to see 7 more papers that published in this workshop, mainly because they summarize and compare a lot of methods, and their feedback and contribution is invaluable. So I'm really going to recommend not just listening to me, but go and read the papers after that. But still, why I'm presenting here, there is much more room for improvement. The groups did a lot of achievements and great stuff, but we have a lot to go ahead. So let's see a little bit what the groups did. Okay. So in general, groups use both as legal encoders and generic encoders as base models and build on top of them. The architecture for NER, the winning team, they're not here right now. I think they're in the Zoom. They use fine-tuning pre-training transformers with additional CRF layer. But was another group that used a hybrid approach. And we know here in the conference, we heard a lot about neurosymbolic neural networks. So they combine something different, but still hybrid rule-based rule-based models with transformer architectures. And it was interesting thing to look at. And of course, zero shot and few shot. And we're going to see some results about that in a sec. Regarding the NLI, we saw groups that's going different directions. We introduced 4 different domains. So we saw some groups building domain-specific models, but we saw also hybrid or agnostic generic models for all domains that we presented. Yeah. Here are the winning groups for the task. Congrats for the teams. Yeah. And as you can see here, it's weighted F1 score, it's average on all 4 entities. What you can see here is that there is much more room for improvement for future research. One interesting takeaway is that it was surprising because what we can see here is that the law and violation performance is much higher than the violated by and violated on. So the span identification of violated by and violated on was much harder. We thought initially it's going to be quite the opposite. One assumption for that is that the agent or the characters in the scenario, in the digital trace, are sometimes abstract to identify. That was one thing that we saw. And the second thing is it might be easy to extract the entities, but it's not always easy to distinguish or understand the relationship between the two. So we saw a lot of confusion between violated by and violated on. So that's another thing that might cause the drop in performance here. I'm sorry. Okay. In general, conclusion. So we saw that traditional encoders like the BERT really excel in this task, and the smaller models often matching or outperforming the larger ones. You can see here in the graph on the right. And generally, as we have long, or at least few years of debate of few shot versus fine tuning, most of the groups won with their fine tuning models, and it's really interesting. And I think it's relate to some works that we saw before in the workshop. And also we saw that legal LLMs groups use legal informer perform on par or slightly better than general LLMs, and it's also very interesting to see that comparison between all of them. Here are the groups for the legal lens and LI, and you can see some groups that and some of them I'm going to present today. Some groups that you can see them here and in the legal lens there. So congrats again to the groups. But as again, you can see that there is much more room for improvement. The best group got 0.85. So yeah. Regarding the conclusion for NLI, so as I said before, the groups used both domain-specific or agnostic or hybrid approaches. The best ones were the hybrid and the generic ones. The domain-specific was worse, and it's quite, I would say, interesting. And for us, it's promising in a way, because that makes the goal to build not a specific type of model for a specific type of cause of action or violation. So that was promising. But we also saw that performance is not consistent across domains. So we see a little bit drop in what we call BPA violation, which is privacy violation. We saw a little bit drop there, probably because the abstract violation neutral labels. Again, there is some ambiguity in this task. Even two judges would probably think different things sometimes. So we can see here it's also in the data. And I think it's also interesting to some of the people here is that smaller models like Pi and Gamma outperform the larger LLMs, and you can see the graph on the right there. Yeah. Okay, some last slides about the challenges. I'm screaming. You can tell me if I'm screaming. Yeah. Sorry. I want to be on time. Okay, cool. Some challenges, opportunities for ahead. Data. Groups told us a lot, and give us so much feedback about the data. Of course, we want more, but of course, also we want to diversify it with more domains. We use 4 legal domains, but we want more. It's not easy to curate this data set, and it's a lot of many and SMEs that work with us. But again, it's very important. And also, we want to deal more or better with the label consensus. So as I said before, the intel and the neutral labels are not always easy to choose, even for SMEs, even for the past lawyer or judges. So it's hard. It might be harder to curate this data set, but we need to work harder and maybe to introduce some ambiguity in this task and take it into consideration. There are many thoughts about that. Also, and it's related a little bit, the evaluation for the NER task was too strict. It was a strict span identification, and we want to change it to something more smooth. So it's also a takeaway. The NLI premise that we use is mainly summaries of legal precedents and cases, and we want to introduce also legislation and talk about legal reasoning and justification, as well as it's very important in this type of tasks. And lastly, efficiency. As we want these models to be deployed in large scale, we want to talk about efficiency and see and measure the cost effectiveness of their usage. So that's again another point for the future. Last slide. Join us if you want to join us. If you're interested in this task, the dataset is there. This is the Hugging Face link. You can go there and play with the data. But we also have a meetup specifically for legal violation detection. It's January 9. There is last spots available, so you can use the link here. And we're happy to announce about on the second legal violation sure task for next year. So stay tuned about that. We have more research interest. I'm not going to cover it today, but we have a break and you can find us later. I want to thank you guys for listening, but I want to thank all participants for 15 countries that contributed to this important task. So thank you.
All right. Good afternoon, everyone. My name is Royal Sequeira, and this is a joint work with my colleague Khalid, who couldn't be here, and I'll be presenting on both our behalf. And our group name is called Masala Chai because we both really like chai. And I work for Georgian, which is a private equity investment firm. So I'm supposed to read this. This presentation is for discussion and information purposes only. Nothing presented today should be construed as investment, legal, tax, or regulatory advice by Georgian or any of its affiliates. The statements and opinions of the presenters don't necessarily reflect the views of Georgian. Any discussion of portfolio companies or customers is for illustration purposes only and may not be reflective of Georgian's investment strategy or the performance of any Georgian portfolio company or fund. There goes my 1 minute, but problem statement, I think Ben already mentioned. So we participated in both the tasks, named entity recognition and natural language inference. And we were interested in checking both or benchmarking both on transformer-based models and LLMs. And I was particularly interested in the named entity recognition task because if you're familiar with the task, this was kind of the solved problem, I think, a few years ago, like especially this well-beaten Connell 2003 data set specifically had about 94% accuracy with the introduction of BERT models. So I was interested to see how this would perform on a more specific, domain-specific data set. And then turns out it is very challenging to perform named entity recognition on a complex task like in the legal domain because of complex terminology and limited annotated data. So we tried different models, basically transformer-based models like BERT, Roberta, FLAN-T5, and then we also tried some of the most recent LLMs such as GPT-4o. And then we saw the best performing system for us was Roberta with the fine-tuning methodology. But what was more interesting was just fine-tuning GPT-4o, and then we tried a whole bunch of techniques. So here, GPT-4o raw is just feeding the input as it is to the LLM, and then trying to ask it to determine the accuracy in F1. And then we fine-tuned GPT-4o. We tried more advanced techniques with DSPy, bootstrapping, and chain of thought reasoning. And then we use this new library, TextGrad, for prompt optimization. So if you see these numbers, you'll be like, okay, that does look okay, like 0.794 or 0.562. But then I put an asterisk there. So for all these three models, less than 10% of the test set had input sequence length and output tags match. And we tried a whole bunch of things. And the LLMs were terrible at these things. Like the tags wouldn't match. There were hallucinations. The LLMs would predict tags that were not present in the data set. So when Ben mentioned violation, violated by, violated on, and law, there would be entities that are not belonging to this label set. And with TextGrad, we tried to take a sort of a slightly interesting approach because LLMs are pretty good for question answering. So maybe reformulating the information extraction task or sequence tagging task as a question answering task could probably be helpful. So I tried doing that, and then that gave slightly better accuracy in F1, but still nothing comparable to Roberta, which we saw in the earlier slide. And then we also participated in the natural language inference task. Again, we tried some of the transformer-based models like Falcon and Roberta. And we also tried fine-tuning GPT-4o. And then we also did a parameter-efficient fine-tuning with LoRa for Llama 3.1, 8 billion parameters. And then that got us slightly better accuracy in F1. So this is the system that we submitted. But then if you see the difference between, at least in our comparison, the difference between Roberta and Llama 3.1 was not that far away. So it was a bit surprising that here's a gigantic model, and then there's Roberta, and there isn't a big performance gap. And similarly, GPT-4o fine-tuning didn't really get us such high results. There were, I think, a whole lot of issues, specifically using LLMs. And then in this case, I guess, GPT-4o. There were two sets of difficulties. Like I mentioned, one, LLMs were terrible at tagging long sequence of text. If the sequence was smaller, then the entity extracted would be okay, but longer the sequence, it would somehow forget, or the entities that it would hallucinate, and then it would recognize entities that were not present in the ground truth. We also saw that there was high variance in terms of fine-tuning. So the graph here is for named entity recognition with GPT-4o, and then it's all over the place. There's no, and then we tried different learning rates and different strategies, but there was high variance during fine-tuning. So the key insights, I guess, here, that smaller fine-tuned models such as Roberta can, at least at the moment, rival larger LLMs. GPT-4o struggles with domain-specific tasks despite using advanced techniques like DSPy, bootstrapping, and prompt optimization. And for future work, we suggest investigating, continuing to pre-train smaller models with much larger legal corpus. That could be helpful. And then also probably pursuing task reformulation. So just like the way we tried reformulating the information extraction task as a question answering task, so maybe some other ways of task reformulation could also be helpful. That's everything. Thank you. And if you have any questions, you can reach out to me. Also, thank you to Daro and LegalLens shared task organizers. They were super helpful throughout the process. Thank you.
Thank you very much. I'll be short so people can enjoy their break. I'm Diana Inkman from University of Ottawa, and Nima was my master's student who was able to submit results on time, and he was very happy to learn in this process. So yeah, is this going up and down? Not really. Okay, let's try arrows. No. How do I go to next slide? Not from this? Okay, let's try again. Okay, thank you. So we participated in both tasks, A and B, as you already know by them, detecting violations. And we used for name entity recognition the BERT model with a spacey framework for name entity recognition. And here are the 4 types of entities that were already mentioned with an example. And we tested on validation data. Well, here's the size of the data, but again, the organizers already mentioned how much. And we use the validation data for testing on our own internal before we had access to the test data, and we don't have access to the labels anyway. And part of the training too as validation data. And maybe one interesting aspect here, the first table shows results on the validation data. And you try different simple models, and maybe the one we submitted got 86% F1 score on the validation data, but when we go to the test data, all the teams got 40-something% or less. That makes me think the test data was a bit different or harder than the training data, which is real case, yeah, or maybe more ambiguity or some other reason. So that's one thing we noticed for both tasks. And yeah, we tried a few other baselines and there were other simple methods, but the BERT model with a spacey framework is the one that we submitted. For the second task, the class is entailment, contradiction, and no relation. Again, here's an example, but again, people can play with the data if they need. And here's another example. The previous one was a no relation neutral class. This is an example of entailment between the 2 articles. And again, we use a simple Roberta model here, and we tried a few other simple ones. And for some reason, the student wanted to add a CNN layer on the top to see so small improvements to that. Here are the results on the validation data. Again, the 4 domains plus the averages. And he was also able to run a small LLM Falcon, but mostly he played with Roberta and the BERT models. And when he did the CNN model, he got from 86 to 88, so a small improvement, 2%. And as we move to the test data, again, we saw a drop, in our case, 72. And is it normal? No, I guess if the test data was more difficult. Not as big drop as for the name entity recognition. So really, I wanted to be short. So we implemented simple models, Roberta, the BERT, with existing tools just for the student to play and learn. And they were quite effective and probably less complex and time efficient. We got decent results in a short time. It's hard to generalize to unseen cases, as probably the test data was more different, I assume. We wanted to look more to graph-based models and knowledge models that we could include about the domain, and to explore larger models for the more reasoning as needed. So yeah, I was short, I hope.
Thank you. We have time for 1, 2 short questions if somebody has a question or maybe suggestions.
I just wanted to ask the organizers, do they think that the data was much more difficult than the training data, or was the same kind?
About the testing, right?
Testing.
Yeah. So we didn't thought that initially. I think the problem, and I touched it a little bit in the presentation. I think it's the size of the dataset in general. So it's probably was harder for any work that we saw here to generalize as much as we wanted. So I think that is the main problem, because we did draw it from the same kind of distribution. So it's not the different method that we use. So I probably refer to the size of the dataset.
Okay, we have Paulo raise their hands first. Yeah, cool. Yeah.
I have a question about if you had a chance to look at errors that the model made, and find any patterns like where it fails in the past, or at least maybe like speculate on why it's harder to generalize.
I don't have insights because the student was in a hurry to submit the results and finish his project, but we should.
So, a very short question on data. Is it an assumption that all the 4 tags are present in the given input, or is that a couple of tags can be missing or something? I mean, incomplete information kind of. Just to clear. And are there any approaches who try data augmentation because you provided them with less data and they synthetically create some data?
Yeah, so the second question about augmentation. So many groups use augmentation. A lot of techniques, I didn't have time to touch with all of them. But I recommend to read the papers. They present really cool approaches. And regarding the entities, we are not expecting to have all entities. So basically the first example was all 4 entities, and the second example that I showed it was only 3, but we also have examples with just 1, just a violation or the suspicious behavior that some tweets is talking about. So we're not expecting even 1. So and that's how we measure the performance. Yeah.
I have a question to the organizer. Have you seen someone who presented contrastive learning methodology, especially for the classification task?
So we saw contrastive learning it was interesting for the NLI, not for the NLR task. For the NLI, okay, so yeah. So we saw interesting use there. What I mentioned about the neurosymbolic network with the transformer-based architecture, it was using contrastive learning. I think it's good. They're not here. I can give you the number of the paper there, but yeah.
Cool. So we have exactly 15 minutes coffee break. So we'll start right at 4 for the last lengthy session. So thank again only had to leave, unfortunately. But thanks to Ben and Daryl for supporting the CERTAS, and of course to all the participants that also made it here. Congratulations. And enjoy the coffee break, and see you in 15 minutes.
Okay, so welcome to the final session of the workshop. My name is Daniel Pietro. I'm one of the organizers. I work at Bloomberg. So the first presentation for for this session is going to be LLMs to the rescue, explain DSA statements of reason with platforms terms of services. And the speaker is Marco, who is remote.
Hello, I'm sharing the screen. Okay. So, hello to everyone. My name is Marcos Promonte, and today I'm excited to present our project titled LLMs to the Rescue, explaining digital Service Act statements of reason with platform terms of service. Let's start with the concept. To set briefly the stage, let's look at the problem. The DSA mandates that online platforms provide the statement of reason whenever they restrict or remove user content. However, these statements often fall short in clarity, using complex, sometimes vague legal language based on the platform's TOS. This lack of clarity makes it challenging for users to understand why their content was moderated, limiting their ability to challenge or engage with this decision. So our solution to help the client is to leverage a multi-agent system powered by large language models. This system interprets and explains source by referencing the specific sections of the platform's TOS that were violated. In short, our goal is to make moderation decisions more transparent, understandable, and contestable for users. For the problem, we start from the dataset, and we built a dataset from 3 major platforms, Booking, Reddit, and LinkedIn, that composed our use cases. Booking represents a commercial environment. Reddit is a community-driven environment, while LinkedIn represents a professional networking environment. We collected the statements of reason from March to August 2024 and used the DSA transparency database that you can see in this screenshot, launched in 2023, to align our approach with the Europe transparency goals. The transparency database plays a crucial role by cataloging source, helping us ensure that our analysis is comprehensive and standardized across various platforms. So let's take a look to the architecture. You can see on the right a visual representation of the architecture, and is composed mainly from 4 main parts that are the vector store creation, that is the module that processes each platform's terms of services by breaking it into meaningful sections and embedding these into vectors using the voyage to low model embedder. This embedding model is trained specifically for legal language, and that's the reason why we decided to use it. Then there's a second module, there is the retrieval and similarity, where we extract relevant TOS sections for each source. We used a combination of cosine similarity and the BM25 in order to retrieve the most relevant TOS segments for each statement of reasons, aiming for precision in matching statements to policies. Then as a third module, we have the refiner agent that improves the relevance of retrieved content by filtering out the unnecessary information. And then the fourth module is the explainer agent that generates a clear, structured explanation outlining the moderation action, the specific terms of services rule that applies, and examples to illustrate how this rule is enforced. In order to validate this approach, we surely had to opt for a human validation, since there aren't datasets that are propedeutic to this kind of task. So we enlisted the 3 expert evaluators familiar with content moderation and regulatory practices under the DSA. They assessed our system output based on 4 criteria: the relevance, accuracy, coherence, and readability, that respectively answer to the following question. The relevance checks if the output aligns with the SOR and TOS. The accuracy ensures key details from the TOS are retained. The coherence ensures that output is logically follows the TOS without adding unrelated content. And the readability, that is only for the explainer, rates the clarity and the ease of understanding. All these validation metrics are used to evaluate the refiner and the explainer, except for that readability that is only for the explainer. Talking about main results, we tested 2 LLMs, in particular GPT-4o Mini and Mistral 7 billion, that are about the same size. Each model demonstrated distinct strength that suit different content moderation tasks. For example, GPT-4o Mini performed exceptionally well in relevance, coherence, and readability across all 3 platforms. It was especially effective at generating user-friendly explanation. For instance, on Reddit, it achieved the highest scores in readability and coherence, showing that this model excels in interpreting structured legal language and presenting it in a format that users can easily understand. While Mistral 7 billion was particularly strong in accuracy, consistently retaining detailed information from terms of services. This is critical in settings where precise legal language is required. For example, Mistral 7 billion scored highest on accuracy metrics, especially on Booking.com, where it faithfully preserved the TOS intent. As a final step, we measured also the validators agreement. In order to ensure consistency, we used the standard deviation to assess inter-annotator agreement. For GPT-4o Mini, standard deviations were particularly low for relevance and coherence, indicating that its explanations were consistently high quality and interpretable. As final findings, it may be useful to highlight that the GPT-4o Mini is optimal for generating user-facing content, while Mistral 7 billion excels in accuracy, making it well suited for tasks where detailed policy interpretation is essential. We have also to the consideration that GPT-4o Mini is not an open weight model, so it is surely more expensive with respect to Mistral. For future work, we plan to expand our system to support multiple languages, making it accessible to a broader audience And additionally, we aim to test our system on a wider range of platforms. And I think that I can thank you for this opportunity and enjoy the rest of the workshop.
Okay, so we should move to the next presentation if you're ready.
Good afternoon, everyone. So my name is Sabinay Narendra, and I'm part of the Machine Learning Center of Excellence team at JP Morgan Chase. And today I'm going to talk about how we leverage large language models for contract negotiation with suppliers at JP Morgan Chase. So first, we investigate the efficiency of large language models like GPT-4 and Mistral on legal documents, how they understand legal jargons, by evaluating it on a data set, on the contract analyze data set, which is a document level natural language inference on 607 contracts. Then we present the first approach using LLMs to compare contract documents with their template, which can be further used to create a catalog of approved clause terms, approved contract terms. And we also show how we can incorporate amendments and schedules into the master contracts to create a combined contract that creates this holistic document, and that can be compared with the template documents. So as I previously said, we frame this problem as an NLI problem. We segment each clause from the concept, from the template into key concepts. And we can consider each of these key concepts as a hypothesis, and the entire contract document can be considered the premise. And the objective is to predict whether the contract document contradicts, entails, or is neutral towards the given concept or hypothesis. And additionally, we perform a reverse analysis in which each key concept from that contract is compared against the template document. So on the contract NLI dataset, we have two tasks. The first task is to classify each hypothesis, whether it entails or contradicts the contract. And the second task is to identify spans from those contracts that entail or contradict that hypothesis. And our internal dataset it includes like 25 contracts, and it goes from June 2007 till August 2023. And it contains various service agreements between JP Morgan and its suppliers. These can be software maintenance agreements, professional services agreements. So we tried GPT-4 model and the Mixtral 8x7B models on both the task on the contract NLI dataset. And GPT-4 model, we accessed it via the Azure API, while we fine-tuned the Mixtral model with PEFT using LoRa. And we use specific prompts for each of those tasks to guide the model's responses. And on the internal data set, since these are scanned PDFs and a lot of messy data, so we used a fine-tuned document image transformer model with OCR to extract relevant clauses. And this was necessary because for amendments, we needed to find which sections we need to modify. So getting those relevant clauses, relevant sections to just modify that part was necessary. Otherwise, we weren't able to like integrate those amendments. And then we used a RAG pipeline to check if the template contract, like each of the concepts in the template contract was entailed by the contract document and vice versa. And yeah, so the experiments showed us the importance of intelligent document chunking and providing specific context to accurately amend and analyze the contracts. And these are some of the results we have on the contract NLI dataset. As we can see, the large language models, GPT-4 and Mixtral models, they outperform the SPAN NLI model on the NLI task. This SPAN NLI BERT model was introduced by the original contract NLI in the contract NLI paper I think it was by Christopher Manning, and we were able to like outperform on the NLI task. We can see the F1 score on the contradiction label is very less for the SPAN NLI BERT model, and for evidence identification, we were able to slightly outperform the SPAN NLI BERT model with GPT-4. On our internal data set, we were able to achieve an accuracy of 96%. So to conclude, we can say like LLMs are like perform very well on the legal documents and can understand legal jargon really well. We were able to generate good results on the comparison of the contract documents with their templates. and which can be further used to identify the most frequent additions and deletions of subclauses, and which can be further used to like create this approved clauses that which can be used for negotiation with various suppliers. Thank you, and this is a link to the paper. Thank you.
Okay, thank you. The next speaker is Vidas Daudaravicius.
Hello, my name is Vidas Daudaravicius, and I'm from Joint Research Center of European Commission, and it's a joint work together with Publication Office of European Union. So, and just before starting, GRC is located in 5 countries, and it's more than 3,000 staff and institution doing research and supporting European Commission in evidence-based policy development. So,
sorry, just a second. The slides are not shared on Zoom.
So every day, European Commission and various public institutions delivers a lot of publish a lot of documents, regulations, acts, roadmaps, impact assessments, and so on. And all these documents usually should be classified according to some taxonomies, classified as type of documents, and very many properties for documents. And this is really huge work for these public entities to publish these documents. And this is like an idea of to get you, let's say, this is Artificial Intelligence Act of European Union that was recently published, and the complexity of assigning labels is really huge, because you might assign artificial intelligence as a label, but there are many other labels that needs to be assigned to these documents, like social well-being and technological change and innovation. So these labels are really diverse and important. And to assign these labels are important for later discovery of these documents. Oh, should I? Ooh. Okay, works. So, and these properties are diverse. It can be some topic labels like Eurovoc, or it can be document type as regulation, communication, or roadmap, proposal, or just a note. And all these properties are used to classify documents. And because there are many properties and with different classes, we came with the idea that maybe instead of using different and fine-tuning different classifiers, just to apply a regular rule of such that if I know your friend, if I know your friends, I know who you are. So, and applying this principle, we take a new document and try to find similar documents based on embeddings, semantic similarity, and then to take these properties of these neighbor or friends documents and to see what properties are used to these documents. And then these properties describe this new document. And this is main idea we came up, and it was very simple to implement. And first we try to look investigate how many documents we need to take, most close or most similar documents. And we analyzed, let's say, top 10 documents, top 100 documents, and the top 100 documents except first 10 items, and to see which documents works best. And then the top 10 documents was, as expected, worked good, and it worked very good for any kind of properties like Eurovoc as theme, subject matters, resource type, document type, and so on. So it was working very well for us. And when we compared with other annotators using Eurovoc annotator. So we used to compare ANIF classifier, EU BERT classifier, and our Cellar annotator. So, and we found that using this nearest neighbor approach, it gave us much more better result than just using single classifiers. So it really boosts from 40% to 60% accuracy F-score. So, and it helped us really very simple development tool to use it in, actually now it's already used in production to annotate many documents. And what it really brings to in practice. So in practice, it's not that only you can have big taxonomies with documents, but in practice, actually, by applying this approach, you can have any kind of classifier. It means, let's say, your government usually is selected and propose some plan or priorities for next 5 years. And usually you want to track what documents or what is the situation against these priorities. And you just take these priorities as descriptions. You find few groups of documents. And when you just applying with nearest neighbors for your new document, you can quickly classify your documents with temporal, simple taxonomies. So this is our approach, what we used. And thank you.
Now, so the next presentation is Abe, who I'm downloading your slides now.
Hello, everyone. My name is Abe. I'm a student at the Johns Hopkins University. Today I'm presenting our series of work on legal retrieval, augmented generation, and legal hallucination. And this is the first paper called CLRG, a data set for legal case retrieval and retrieval augmented analysis generation. So our motivation is simple. Say in the common law system, we have a lawyer who wants to create a piece of legal analysis that's appearing in some legal documents. This lawyer needs to find some evidences that are coming from precedent cases and use information from them to combine into a piece of analysis. And so this pipeline can be otherwise viewed as a retrieval augmented analysis generation problem. And we're interested in using an LLM to assist the writings of lawyers. So in our paper, we focus on the two separate components of this pipeline, retrieval and generation. So we introduce case law evaluation and retrieval corpus, CLRG. It is a massive data set containing 1.84 million of US federal case law. And they are like the full text documents. And we also have 23.7 million of passages, which are the chunks of those documents. And we did this pre-processing because we want to enable some retrieval models which don't support context over 512 tokens. And let's begin with how we define a query. So a query is basically a chunk of the document. And how we proceed is that we first identify a case citation and we expand a 300 words window around this central case citations. And the goal of the retrieval is to recover this central case citation that will be masked during the retrieval stage. There's also other case citations, which is highlighted in red here. We don't retrieve those, but these are some actual data that we consider as a part of our ablation studies. And I recommend everyone to read our full paper to know more details. There's also a couple more data constructs here. So the blue is a citation to a federal statute. They are very different from case citations. The brown is a direct quotation that's citing from a case. And for our main investigation, we focus on case citations that don't involve direct quotations. But we also did ablation studies for retrieval with the direct quotes. So showing some main results, we tested different families of retrieval models with different recall at k passes, and this is recall at 10 passes. You can see that the fine-tuned DPR models have the best results, whereas BM25 is like the second best, or like the highest among the unfine-tuned versions. And late interaction models particularly don't generalize very well on this data set because it is worse on long context retrieval. So the takeaway here is BM25 is very good, fine-tuning helps. And then the second part of the inquiry is we're interested in learning how well can LLM generate legal analysis. So we define this task with identifying what are the legal analysis in the case document, and we locate a paragraph that's of legal analysis. And then we want to kind of take this paragraph away and write a new paragraph of legal analysis based on the previous context of the identified paragraph. And then we want to compare the gold paragraph, which is the paragraph we identify with the LLM generated paragraph, and evaluate with some generation metrics and citation metrics on like how well the generated paragraphs makes the citation that it is supposed to make. So this is the input. We have like a set of relevant cases that the generated paragraph should mention in the generation, and there's also the previous context. And so showing some results, we did more evaluation, but just partly the results. In terms of text quality, GPT-4o has the best Rouge L scores. It also has the highest citation precision and recall, but it has the most number of false positive citations. And so we suspect that the kind of part of the high performance here is coming from making many citations, even if they are non-existent. And so this raises further question as what is considered good legal analysis? It seems that text quality and citations are not, sufficient metrics for this evaluation because there's the inherent factuality and logical components of legal reasoning. And so let's stay tuned for my next presentation, which is a scrutinization of legal evaluation.
Okay, thank you. So the next presentation is Maxim. If you can come, I saw you on the slide, so I'll find it.
Hello everyone. I would like to present our work empowering air travelers, a chatbot for Canadian air passenger rights. Yep. Okay. So I'm pretty sure all of us experience some challenges during air travel. And well, some people argue it's especially challenging in Canada, and this is due to multiple factors. Specifically, it's deficient regulation. So there was a report that citing that Canada lags behind, especially some of the peer countries in Europe. And as evident by the public outcry on the left, this also evident by some lack of law enforcement. So all of this has led to growing passenger concerns, which are currently handled by a group of volunteers that created a Facebook group and tried to deal with the issue on a case-by-case basis. So to alleviate this problem, we propose a chatbot for Canadian air passenger rights. The goal of this chatbot is to provide quick answers on passenger rights related to their specific issue, and also support them to make informed decision for their specific case. The key feature of our chatbot is that it able to understand advanced narrative in the input And it also provides hallucination-free responses. So the benefits of our chatbot is timely support of air passengers, easy access to regulation guide and step-by-step procedures, and also reduced volunteer workload. So the chatbot architecture consists of is based on information-seeking dialogues and consists of three components. The first component is input understanding, which has two subcomponents: contextual queries isolation, which has the goal to isolate the current user input from the rest of the dialogue. And then the second subcomponent, the compositional query generation, they try to decompose the other isolated user query into multiple statements or questions that can be used to retrieve relevant documents. So the second component is our retriever that communicate with a knowledge base that basically represented as a vector store. Once we retrieved the documents, we passed both the documents and the queries to the third model, which is answer composition module. And the goal of this module is to take queries, the documents, pack them together, and present to the user. Here is a specific example. We can see, like in this input, the user entered issue that complex contain multiple aspects. Specifically, the user is talking about a canceled flight and damaged luggage. So then we pass this input to our input understanding module and decompose it into queries after contextual isolation and query decomposition. Then we use each of these queries to retrieve the relevant documents. And finally, we present the answer to the user. Okay, here is our implementation details. So the chatbot is implemented as a client-server architecture, where we have front end that implemented as with the help of React framework that basically take the input from the user and present the information. And the backend. So the backend uses OpenAI API to perform contextual query isolation with zero-shot prompt, and also uses the compositional query generation prompt to do that. Also in backend, we have a knowledge base. Essentially, our knowledge base is just guides, law, procedures that we were able to find on the internet. And we use contextual to store this information in a vector store. So to understand the effectiveness of our chatbot, we perform a user study where we compare the effectiveness chatbot versus Google search. So we recruited 15 participants without any prior experience with using our chatbot, and measure and gave them to solve some to find information related to some of the common travel issues. And then we asked them to answer some questions related to four usability aspects. So this is the results of the usability test. As we can see, the participants reported that the chatbot is useful, and they also satisfied with it, while it's performing similar to on the aspect of ease of use and ease of learning. From the qualitative feedback, we found that the user liked natural conversational interaction with the chatbot. They also reported that it is more convenient than Google search. However, on the downside, the users reported that sometimes the chatbot not able to understand the problem. We also perform hallucination analysis. This is especially important in the law domain because the cost of the error is very high. Yeah, so on the left, you can see some of the real cases when hallucination of the model led to very bad outcomes, like the airline, the air passenger sued the airline because the chatbot provided some hallucinated response. And there was another case when chatbot provided to the user to break the law. So to avoid this, we try to understand to what extent our chatbot help to alleviate this issue. Yep. So we compare chatbot to standard track approach where we manually evaluated the results of the RAG output to understand the rate of hallucination. So we found that 27.5% hallucination versus 0% in our chatbot. So the limitation of our chatbot is to that sometimes the provided answers might be too complex and responses might be not that much connected to the user input. And currently the chatbot doesn't support mixed initiative. This is something that we're planning to address in the next iteration. Thank you.
Hello, everyone. I'm Larissa Mori. I'm presenting today our paper titled The Impact of Formulaic Language on the Performance of Lexical and Dense Retrieval Methods. This is joint work with Carlos, Dr. Yuan Yi, and Dr. Mario Ventresca. We're from the Edwardson School of Industrial Engineering at Purdue University. So the first part of my presentation, I'll explain the context of formulaic language in the Court of Justice of the European Union. But the idea goes beyond this because most legal language is also structured and repetitive. And we're analyzing this for the text, for the task of performance of lexical and dense retrieval methods. And I'm calling the Court of Justice of the European Union SJEU for short. So to understand what we mean by the formulaic language in the CJEU, I'll talk about some characteristics of the citations in this court. The citations are at the paragraph level. So we have not only the indication of the case, but specifically what paragraph in the cited case it is referring to. The other elements is that the citations rely extensively on verbatim quotes and paraphrases and also on judicial formulas. And here I'm showing you the overlap between the passage in the citing case and the cited case. And usually the language is very repetitive for the CJEU. So we're thinking about the impact of this repetitive and formulaic language for the task of legal passage retrieval. And the task is given a query that is, for example, a legal argument, what passages in prior cases that support this query. And the idea of focusing on passages is because it should be focused on specific legal topics, and it's also more interpretable. And we want to understand mainly is how lexical methods compare in terms of performance with dense methods. So here we compare the lexical models, which fundamentally are fancy versions of counting the number of words in common. There's no pre-training. Whereas for dense models are models based on generating vector embeddings in the paradigm of transform-based models with hundreds of millions of parameters and pre-trained on large corpuses. And we're comparing here a set of models in yellow for lexical and in gray for dense models. For the purpose of showing the slide, you can see results in detail and the paper, but we just want to visualize the ranking of the models. And we see here that the fine-tuned model outperforms all the other models for most of the metrics. But we see that BM25 is also very competitive, especially, for example, with Ada V2, which is the model for one of the models for generating embeddings by OpenAI. So the second question that we want to understand then is, when do lexical methods outperform the dense models? And what we find is that this happens when there's lower presence of verbatim quotes and paraphrases. We analyzed this specifically for the BM25 model, and we're comparing it to the Ada V2 model. And we're using 3 metrics. We perform the qualitative analysis, but also quantitative analysis. And the metrics that we are using to compare those cases are the number of n-grams in common, the mean added distance, and the longest common subsequence. And just for visualization, I'm showing here comparison in the first row is when both the lexical and the dense model have 100% recall at 5. And we see here that there's a much higher overlap highlighted in pink in comparison when BM25, the lexical model, has 100% performance and Ada V2 has 0% recall. And the lexical overlap is much lower. And this aligns with the quantitative metrics as well. And we also have some plots and comparisons, and we invite you to check more details of the experiments in our paper. So the takeaways for our analysis is fine-tuning has the best performance overall, but with the added cost of computational and energy costs associated with fine-tuning on the domain-specific data set. Lexical models are often competitive with off-the-shelf dense models. By off-the-shelf, we mean models without fine-tuning. And BM25 has better performance when there are less verbatim quotes and paraphrases. So one of the limitations of our paper is that we're using citations in actual cases for queries and the ground truth, but there are many limitations to this. Mainly, citations are non-exhaustive, potentially biased, and the query is influenced by the cited paragraph. So there's a lot of room for improvement in terms of better data sets and better queries for this task. So thank you for your attention. I hope you will check our paper. And I hope we can stay in touch in next iterations of the workshop as well.
Okay, so we can do a joint question answer session, but we're running a bit behind schedule, so we should limit this to around 5 minutes. So, do we have any questions? It works.
I think that's worthwhile clarifying, Clark, as well. I think it's a very general point in a sense. I mean, I just want to also get your opinion on this, where everyone in the legal retrieval works mostly on maximizing recall. When you do for maximizing precision, I mean, recall is okay to get some traits and you find out if it's present or not. But technically, there is also some authenticity modeling going on behind. I mean, I might not cite all the cases that's present. I mean, ton of cases may deal with the same concept or something. There is some authenticity modeling, as in there is some degree of authenticity a case carries because this has been judged by some person or this has been judged at a higher court or something. So is there a way we can model such things for having a better precision rather than just recall? That's first question. And the second question is to also think on, I think it's more on Larissa's, just to understand on the limitation of using verbatim codes also reflects back or pushes back, because what's the use of retrieval? If I already know that verbatim code is already present, which means lawyers already know that a case is where I copied from. So are we really reflecting upon the actual task where we do not even know what the verbatim code is? I mean, putting it otherwise, if I know the verbatim code, I know which document I have copied it from. So is there a need for retrieval in such cases even? Or is the formulation of task need to be somehow decoupled from this verbatimization somehow to make it more legal utility in that sense?
So, and in terms of the retrieval, I think that it would be interesting to have a data set where we actually have the queries that a lawyer would type in when generating a legal argument for a decision. So we would have so that the use case would be more closer to reality. And yeah, I think that's a very interesting question. That is something that I would be interested in discussing offline as well. And for now, because manual annotation is expensive, using citations is the what we currently have. And but still, I think that if you have a question or have a topic that you're interested in and you want to retrieve all of the cases and understanding what is the map of the legal understanding in that for some topics, I think that that's still useful, the retrieval in these cases.
Thank you, Santosh. I think the question about precision is great. The other thing that's related that I thought about is so currently we define relevance as when a case is citing another case, we call that relevance. But you know, there could be cases that are just analogical to each other, and the lawyer could use it, but maybe there are just fewer cases that actually make the citation. So I think it would be also interesting to investigate can we discover these kinds of analogies without you know, previous citations. I've been thinking a lot about, you know, could there be something in the embedding space that shows such similarities? And I think that's one way that we can sort of think about precision in alternative ways. Okay, thank you.
So this question is from Dataset. They define in the query system that there is a sample citation, and after the sample citation there are some more citations provided. So why this kind of task setup? Because if there is already citation provided, the sample citation have a couple of citations, then what the other citations are doing? Is this already confusing the way retrieval argument generation, retrieve the best citation? I didn't get the task structure complete.
Yeah, I think that's a valid question. Due to the time limit of the presentation, I couldn't provide a very thorough justification. But we do have, say this chunked document, which we call a query, have a list of citations, but we provide different data views. So in some data views, we remove only the central case citation and we try to recover those. But in some other data views, we remove all the case citations that's appear in the query. And then our goal is still to recover the central case citation, but we kind of remove those noises from the queries. And it turns out that the all removed cases are actually like more difficult because they also remove some relevant contextual information that are making the central case citation more difficult. Look at our paper. We also divide into the direct quotation scenario and the indirect quotation scenario. Indirect means just you don't have any direct quotations with the cited cases. So this only removing the central citation and the citation don't involve a direct quotation is actually the easiest query. So that's why we use it for our main task. But we also have just a thorough ablation studies on the kind of 4 different types of queries that you can go through.
Thank you. I have a quick question actually, also for both Aben and Lisa. So it seems like there's in general different strengths to lexical matching and 25 method and then retrieval. Like have you run experiments trying to combine them?
Sorry, can you elaborate a little bit on the combination?
So if for example, you can get documents, for example, from sparse retrieval, you can get documents from dense retrieval, you try to fuse the results or try to mix them in anyway.
Yeah, so we did try with re-ranking. So we use BM25 to retrieve a set of passages, and we use a cross encoder to re-rank. And the interesting results are, I think, sometimes cross encoder actually can even make it worse, because it seems that I think this is somehow confirmed by Larissa's results that lexical models are pretty good, and without fine tuning, it seems that sometimes BM25 just better even than cross encoders.
Okay. Any other quick question? Okay, thank you again for all the speakers from this session. In case you didn't realize, the session was on retrieval, primarily as a topic. Okay, so now the first talk from the next session is also Abe.
Oh, I think it's me, right?
Yes, yes,
Okay.
we are. Just give me 1 second. Is it here?
Yes, it is here. Yeah, this one.
Test. Hi, it's me again, Abe from Johns Hopkins University, and we are continuing from our previous presentation on legal retrieval-augmented generation, and we want to do a more fine-grained evaluation about the hallucination phenomena, and we want to propose some evaluation metrics for that inquiry. So let's recap what happened 20 minutes ago. We introduced this retrieval-augmented analysis generation task. Here I use a paragraph level notation. So the goal is to, given first the previous context, which consists of paragraphs up to T-1 paragraph, and a set of relevant cases that the generated case is supposed to cite, we want to sample the next paragraph. And we want to compare the next generated paragraph with original next paragraph. So here, we are seeing that we evaluated with this comparison, but does the similarity between the 2 paragraphs necessarily mean bad? So let me give you an example. Say this is the target gold paragraph, and it's making a list of case citations. And we generate something that's also citing the exact same cases, but yeah, sometimes the LLM would choose to elaborate each of the citations, which is also acceptable in legal practices, but this is definitely very dissimilar from the gold standard. So using some text quality metrics or some comparison-based metrics, it would rate this generation as unfavorable, whereas in practice, this could be very favorable. So we give this neutral terminology gaps, which refer to dissimilarities between machine-generated and human-written legal analysis, but we use this neutral connotation to indicate that it's not necessarily errors or hallucinations. And we have a very fine-grained taxonomy consisting of 14 categories, and this red here, target mismatch, and its subcategories are the forms of legal analysis that are like acceptable, but they are dissimilar. Like, so there is a mismatch, but it's not really considered as hallucination. Whereas intrinsic gaps and the other one, citation content mismatch, are considered as strictly hallucination. And I'll go briefly into like reviewing these. So intrinsic gaps are the gaps that derive from the internal inaccuracies of LLMs in following prompts and previous contexts. So just a few exemplary subcategories. For example, redundancy when the generation has a lot of repetitive statements, or structural mismatch because we are continuing to generate a paragraph. Sometimes LLM might just conclude the case. So we call that a structural mismatch. And then extrinsic gaps, we have target mismatch, which we discussed before. It's acceptable forms of dissimilarities. And then citation content mismatch, which is when generation does not faithfully or factually reflect the content of the cited cases or just straight up hallucinate citations. So the takeaway here is that target mismatch is okay. Intrinsic gaps and citation content mismatch are hallucinations. So based on these fine-grained taxonomy, we built some detectors to figure out what kinds of gaps that the LLMs is making. So our pipeline is that we have K in context examples, and we judge only the parent categories. So intrinsic gaps, target mismatch, and citation content mismatch. I know that we said we have like 14, but it's very hard to obtain human annotations on those. So we obtain like 20 in context examples of the categories, and we prompt them to some base models and build a detector. So some evaluations. So basically we use Llama, Mistral, GPT-4o, and you can see some models can give a high precision or recall around like 80%. And the takeaway, the takeaway here is that a GPT-4o can detect accurately, and Mistral is good among open source models. And we also did further error analysis of different detectors, since you notice that they might not be perfect. So the message here is that Mistral tends to overpredict the presence of gaps, whereas GPT-4 and Llama tend to underpredict. So we use these detectors. They are not perfect, but that's what we can work with to reevaluate clerk generations that we talk about. And the results here are saying that around 80% of the generated legal analysis contain hallucinations like intrinsic gaps and citation content mismatch. And especially note here is that so G3 means citation content mismatch, and you can see that GPT-4o has has more like citation content mismatch than Llama, and this result is actually it's consistent with our prior findings that GPT-4o has more citation false positive because the G3 category contains the scenarios that the LLMs hallucinate citations. So the results are consistent with each other. And some future works, we want to build upon more like general purpose legal models, maybe through continual pre-training. And we are also thinking about using argument graphs to augment generation. And we also want to kind of expand the gap evaluation framework onto more general domains. And lastly, I want to market our team at Johns Hopkins to, guys should follow our series of work on legal NLP, and also market myself. I am an undergrad at Johns Hopkins University. I'm applying for fall 2025 PhD programs that's US-based and summer internship. So thank you so much for following my presentation.
So it gives you faithful modeling of domains, and it also demands very costly expertise to construct such domain models. Whereas the recent works are mostly focusing on classifying the legal conclusions, but they lack explainability or any explicit reasoning. So the key question we want to raise is whether and how the process of legal reasoning should be represented, whether it should be represented explicitly or whether it should be left to the opaque components, just produce more data, give it to the models, and expect that deep expertise will be learned by models just by giving more data. So our idea is to examine the historical integration of legal expert knowledge systems into the current systems and advocating for its revival in the current generations. So we emphasize for this paradigm shift, integrating those expert models and current data-driven approaches moving forward. So as we all know, legal reasoning is a complex process. Very simplistically put, it's an if-then-like inference, which you establish from various sources. But in reality, it's not as easy. It's a logic-like inference, but it is interwoven with areas of ambiguity, vagueness, and human discretion at the end. And as you know, legal orders evolve over time, which means you need to adjust according to dynamic world. And rules are overridden by exceptions. You have superior conflicting rules and even distinctions raised by precedents. And finally, you can see legal argumentation is a competitive theory formation before an arbitrator to decide on the outcome that is mandated by law, but also extends it equitably. So legal reasoning is such a complex process, and we are trying to model with the existing models without taking account into all the nuances present inside it. I just want to give you a quick survey of how knowledge-based systems or expert systems used to be working in the past, so that we all go with those takeaways of what those systems are, so that the current community at least get aware of these systems. The past era started with rule-based systems such as Prolog, augmented transition networks, where these are specific languages to represent rules, etc., which are more like derivative kind of models rather than argumentative. Then came case-based approaches such as Hypo, Taxman, Cato, where these are more like an adversarial nature of law, where you use analogical reasoning and it's more like a dialectical frameworks. Then we have hybrid approaches mixing both of them, such as Cabaret, Grabe, and Bank XX. Then finally, we have this prediction coming into picture with approaches such as Smile and Smile plus IBP, where they used to predict the legal issues using this case-based reasoning approaches. Then the main important three characteristics which legal context come as values, times, and procedure. It's always you have teleological reasoning present. It's not always just the outcome that's important. It's also the conflicts of values and how do you derive what purpose you are trying to serve, etc., and how do you model them into your modeling process. Then you have temporal logic, where the cases evolve over time. You have concepts evolving over time. How do you integrate them into your modeling scenarios? And then procedure, because case to be argued is linked to which context the case is being even considered. Are we even modeling this currently at this right age? Then we have theory construction approaches, because the job of a lawyer is to construct theory to convince someone and prove that this theory is better than the other lawyer's theory. So are current models even capable of constructing such theories? And you also have rules. You also need to balance values and also rules and preference, where there are rules, but there are preferences, values, larger society at play. So how do you balance all this going forward? And then comes the computational argumentation mechanisms, where you represent arguments as schemas, where you have stereotypical pattern of reasonings, such as you have a claim, you have supporting premises, exceptions, etc. Are the current systems even modeling this, where expert systems used to do all of these scenarios? And then we have abstract argumentation frameworks, where you represent arguments, then you have attacks between arguments and write rebuttals according to them and proceed a dialectical way. And there are some generalizations of this argumentation framework, such as ADF, which are called abstract dialectical frameworks. I think these are the huge literature which expert models or traditional AI and law has given it, which I think the current legal NLP are neglecting it and moving towards more data-driven approaches, where we try bag of words, neural classifiers, just BERT and domain-specific BERTs,
and trying applying all these NLP models to legal text with no or very little explicit domain representation. And we evaluate mainly on our quantitative metrics, focusing on high-level classification tasks, which may not be even our end goals. But you also need to understand the case outcome variables are very much contextual. They are shaped by the time, procedure, and the socio-legal purpose. And we are only accounting for the binary variable we get at the end of the day, because we are trying to prioritize our convenience rather than the actual utility that this provide. Yeah, so the current evaluation procedures also lack all the nuance and legal argumentation and complexity present underneath. And these are something which, as a community, we need to look forward to. And also the main assumption we come up with, improving benchmark performance implies that these models encode more extractable legal knowledge. Is it really so? Then we also did only just the explanations deriving from attention maps, integrated gradients, and trying to compare against expert identified words. But expert annotations itself vary significantly. What are we really comparing against them? That's the main question we as a community need to ask ourselves. Then even the saliency maps, whatever we produce, there has been some works showing this to experts that do not even accurately identify outcomes. So how do we even need to quantify or even define explainability in that sense? And also, as we know, models predict correctly for various wrong reasons. So rather than just focusing on our end goal of using some shallow word signals to get some benchmark performance, we need to grow beyond that to think the utility and the purpose beyond it, and look for the better correlations we are really looking to have these metrics. What exactly lawyers need is to explain why a case is a proper application of law. And you have to provide a justification that is rooted in jurisprudential theory, presenting equitable arguments so that you can present and you make some conclusions deriving out of them. And finally, they must withstand appeal review and public scrutiny so that we understand why is it even giving such a conclusion in such a particular case. And with the current rise of generative models, people are testing with different prompting strategies, having chain of thoughts, legal syllogism, etc., with IRAC procedures. But even the challenges such as manual performance assessment, etc., are lacking, and people still rely on this automated metrics as end goal, classification, labels, etc. So this aligns with our explainable reasoning, but we need to rise above that and come up with future things. So I'll just list some open challenges before I conclude. One, we need to combine knowledge and data effectively, because knowledge-based expert systems really deserve the merit attention of current legal NLP community because of the authenticity they provide. And those systems should be integrated with our deep learning concepts and also the conceptual representations, which I say as intermediate representations where lawyers can understand what we are communicating to these models, etc. And of course, the data utilized has been emphasized a long times, where this data have limitations coming, where they come from, at what phase of the court procedure they are coming from, and how do we represent them, and the data selection bias, because all the case documents are not available. Only a couple of courts documents are available, or even only specific subset of cases are presented. So these are all the limitations which we need to list down as we move forward. And as I discussed, the temporal dynamics part, where we are not accounting for time in any of our modeling, needs our attention, and need to also think how do we need to update these models with time. And for that, we also need to look at how do you detect these overrulings, how do you incorporate model unlearning so that it forgets the past knowledge and detect updates in the beliefs and knowledge. And as I said, domain model construction, where constructing such rule-based models are tough, but we have currently LLMs. Can we take help of these LLMs to construct those semi-automated rules so that we can use those rule-based systems and get back to them again? And finally, currently, we have these fields of argument mining mostly done, where we need to evolve to argument generation, have the dialectical arguments coming into picture so that we construct that theory of jurisprudential, what we are looking forward. And finally, without emphasizing role of evaluation, I may not complete this. So ideally, we are looking for evaluations which tell the tangible progress of a field towards some optimal legal argumentative systems. But unfortunately, we are stuck with convenience over real informative evaluations. So maybe we should look for better metrics or better way of evaluating our current things. With this, thank you.
Okay, hi everyone. Sorry for the previous hustle. My name is Yanai Lazar. I'm presenting on behalf of Sahil that couldn't be here today. He was the first author. He did all of the work. So if you have any really hard questions, email Sahil. Okay, so today I'm going to talk about imitation. This is an example of a generated image that I got with text-to-image model. And you can probably recognize this person. This is Johnny Depp. And it works pretty well. This is another image. Again, I tried to generate this image using a text-to-image model, and this was supposed to be me, but it's not quite there. Okay, so if we're going back to LION, one of the big data sets where people train text-to-image models like Stable Diffusion, I don't appear at all in this data set, so I have 0 counts if we look at all the captions. On the other hand, Johnny Depp appeared 270,000 times. So basically what we're trying to find in this work is the imitation threshold. So me on the left, I appear 0 times and there's no imitation, right? Johnny Depp on the right, 270 times in the training data, pretty good imitation. So now we're asking basically what is the imitation threshold where below that count, okay, there's not enough training data or images that the model is able to imitate that concept, in this case, the face of a person, but above that, it's enough. And why should you care, right? Like what I showed you so far doesn't have to do at all with this workshop. So we have a few reasons. One of them is copyrights. Here's a few images from Holly and Gret. They're very nice. And those are a few images that we generated with text-to-image model. And they look pretty similar. And it took less than $1 to generate all of them. And obviously, this person probably doesn't want to have that. And there's been a lot of copyright claims against those companies that created those text-to-image models. So this is one of the implications of this one. Another scenario is privacy. So while Johnny Depp is a public figure, I'm not as well known yet. And I might not want my images to be generated by those kind of images. So I want my privacy to be kept. So this is our formulation, okay? We have those text-to-image models. They were trained on a lot of data. So we're asking if we were to generate, or if we were to train the same model with n prime images instead of n, would the model still be able to imitate that concept? So if, for instance, I had 100,000 images in a training data, would the model be able to generate my images? So the naive kind of solution, but also the ground truth, would be to use counterfactual training. So let's keep the same training data the same, the training protocols the same, but now I only change the number of images that we give to, let's say, Johnny Depp. So now I train the same model with 10 images of Johnny Depp. Would the model still be able to imitate him? And then we do it with 100 images and 10,000 images and so on. And then we find the number that below that it's not enough and above it is. But obviously this is very expensive. Each one of those trainings is incredibly expensive, especially in academia. We cannot afford to do that. So instead we go on the observational approach where we need to make some assumptions, but using those assumptions we can estimate a solution or a number that estimate the true imitation threshold. And if you're interested, you can ask me about those at the end. Okay, so we propose an approach called mimetic square. We start with a bunch of prompts, like a painting in the style of, and then one of those artists. We collect a bunch of different artists or different people that we use as our concepts. We generate then a bunch of images, and we will compare them to the training data, the images from the training data that is the ground truth. And then we'll get on the left the low imitation, on the right the high imitations. And we want to generate graphs that looks kind of like that. So again, on the left side, those will be very infrequent concepts. On the right, very frequent concept. And we'll find the place where there's a switch between no imitation to good imitation. So for the setup, we have 2 concepts, human faces and art styles. For each one of them, we created 2 data sets that have some differences between them. So we have celebrities, politicians for the human faces, classical and modern art. And for the pre-training data set, we have 2, Lion 2B and Lion 5B. And we use 3 train models. The results show that the imitations are around the imitation threshold that we find or that we estimate. What happened? Oh, Zoom. Okay, I'll just continue. I'm towards the end. So the imitation threshold that we found for most of them are between 100 to 500 images. Those are pretty consistent across the different models that we use, the different data sets, and across the concepts. Okay, so again, sorry. To sum up, we proposed this new task, we call it the finding the imitation threshold, or FIT. We proposed a new model that estimates that threshold. It's called mimetic square. And we found some interesting results that estimate the imitation threshold to be between 1 to 500 images. And that's it. Thank you.
And the paper is not archival, right?
Right.
So where can people read the paper?
It's on archive. You can look it up.
Okay. Hi, my name is Shufei. I am a PhD student from Queen's University in Canada, and today I will be presenting our work, Misinformation with Legal Consequences. This work is done with Radan Shayanfar, Rohan Bamboria, Samuel Dahan, and Sharan Zhu. So our work is focused on detecting misinformation on social media, but from a legal perspective. So we want to assist policymakers and content moderators assess potential legal violations that can arise from misleading or false information. And so we designed a new task based on Canadian law, and as well as a new data set to support the task definition. And we maximize efficiency by utilizing both legal experts and crowdsourced annotators. So here's our annotation pipeline. So we first use crowdsourced workers to assess checkworthiness. And this is a fact-checking principle that looks for some factual claim that is of concern to crowdsourced workers. And then we pass those to a legal expert that uses our legal issues to assess potential violations. And then we evaluate how an LLM compares to the legal expert given the same resources. So we give it a legal database as well as web search via the Google Search API. And so we define our task with 3 possible labels. So it's either misinformation with legal consequences, not, or we can also have unclear in cases where the text isn't completely ambiguous, but there may not be evidence, for example. And so we gather 11 legal issues from 4 broader legal topics, and we gather these from legislation at the provincial civil court level, as well as the federal level, as well as case law, official bulletins, and policy opinions. And so the main distinction between legal consequences and not is the distinction between a claim and an opinion. So a lot of claims found by crowdsourced workers turned out to be mixed with political opinions, and our legal experts say that it can't be a legal violation. And then we perform a check for whether or not there's evidence available. Again, this is through Google search. And then we move on to assess our 11 legal issues, which each have a legal test and optionally some defenses. So for example, if a social media post is quoting someone else, it can't be a violation. And so we compile a data set of 1,500 tweets on the Russia-Ukraine conflict before crowdsourced checkworthiness. And then we further sampled 700 of these for legal annotation. And then this is the data set distribution and the most common legal issues. We find that our data set has roughly 100 positive samples. So that is a roughly 11% positive rate. And so we evaluate, or sorry, 13%, but we evaluate with both a binary setting and a 3-way setting. The binary setting is where we take unclear class to be negative. And then we test both a 0-shot setting, so we don't give the LLMs any legal context. We test LLMs, by the way. We test all of these LLMs that are listed on the screen. And then we also introduce the legal documents as well as web search using retrieval-augmented generation. So we test 2 methods, Brown and Flare.
What?
Okay. Okay. Yes, and then we also add a constraint to just say, ask the language model to not refuse to answer. And so for time's sake, I won't go over the full results, but here are key findings. In general, the performance on our task scales with general domain performance. So GPT 3.5 doesn't perform as well as GPT 4.0. Retrieval doesn't help as much as expected. It does improve the performance by less than 10% F1. But in general, even when we provide LLMs with like gold evidence and the gold legal document, the performance still doesn't improve much over zero shot. And then finally, the larger models follow our prompt constraints more effectively. So smaller models are more likely to refuse even though we tell it not to, which is both good and bad. And we do investigate why retrieval doesn't necessarily help. In fact, it sometimes causes what looks like model collapse. If you look at the figure on the right, like this blue bar indicates that it's just always predicting unclear no matter what. And we think it's because of the retrieval frequency that differs between the two methods. So in general, we propose a new task that LLMs still struggle with, and we hope that the data is useful for future work. Yeah, thank you.
Hello, everyone. My name is Odysseas Lafanis. I'm going to present you LAR-ECHR, a new legal argument reasoning task and dataset for cases of the European Court of Human Rights. Okay, so the most established legal benchmark, as you all know, is Legal Bench. It is designed for LLMs and it has 162 legal reasoning tasks, and it's based on the US legal system. It has basically question answering. Most questions, most of them are multiple choice. On the other hand, in the EU legal system, a very famous dataset is LexGlu. One of the most widely known tasks are legal judgment prediction tasks, as we have already seen earlier in the workshop, and they are classification tasks and they are focused on BERT style models. We are introducing a legal argument reasoning task and a corresponding ECHR dataset where the LLM, given some facts and arguments and 4 continuation options, has to select the most plausible argument that continues the previous arguments that are given in the legal case. To create this task, this dataset, we had to select the most appropriate reasoning arguments. To do this, we used some prior work called LAM-ECHR. They have done legal argument mining, and we have used their annotations. More specifically, they have annotated the agents, so essentially who is speaking and who is making the argument. They have 3 possible annotations for this. It could be the government, the court, or the applicant. We decided to only use the court arguments for the dataset because the court arguments are the most objective and most accurate in reasoning. And we also have selected the annotation application to the concrete case. This means that this is the type of the argument, and this means that the arguments that we have selected refer to the facts of the case, to the specific case. Additionally, now that we have selected the suitable arguments for this dataset, we had to select the 3 distractors, the 3 incorrect options. To do this, we have computed the embeddings, the embedding of arguments from different cases, not the case that we are creating the new data point. And we have selected the arguments that have the largest cosine similarity score. But this has an issue that some arguments, essentially the ones that have very, very high scores, are paraphrases of the original argument, or sometimes they are exactly the same. To avoid this, we set a threshold at 0.8, because empirically we found that scores below 0.85 are almost always have almost always a different meaning, but they talk about the same topics. So what this does is that we select similar topics, but not the same sentence. Additionally, we have created a specific a chain of thought prompt specifically for this task. And using this prompt, the LLMs give us this response in this format. They first analyze the possible options. As you see on the right, the continuation options. The LLM provides its opinion on each one of these options. And then the LLM explains why it decided that and makes the decision essentially on which option is the correct one. At the last step, the LLM just outputs a single number so that it helps us with the extraction of the correct answer. Now let's dive into the results. We have evaluated 3 LLM families, GPT-4o, Mistral, and Llama models. We see that GPT-4o has the greatest performance. We also, for comparison, we also saw legal bench results. And a very interesting result is that even though they are talking about different legal systems, LAR-ECHR is in the European legal system, and legal bench is about the US legal system, the model rankings are the same. And also, I would like to add that we see that in our benchmark, the top models can be distinguished more clearly. So, for example, GPT-4o and GPT-4o Mini have a greater gap, which is better for comparing better and better LLMs. To conclude, the dataset is available on Hugging Face, and a very important note that the process can be replicated for any legal system if we have the necessary proceedings and some argument annotations. And we advocate strongly that these models and the models tested on these datasets are used only as supporting tools. Thank you for your attention.
Hi, this is Yeun. I am a master student at the University of Seoul. I will be presenting our Korean legal language understanding benchmark dataset. We created the first ever verified dataset to see how well AI can understanding Korean legal languages. We put various models through their paces, both with and without access to Korean statutes and precedents. Lastly, we compare how different LLMs stack up against each other. While GPT-4 was crushing it on USA bar exam, it still faced limitations in non-English context and non-standardized legal tasks. Most testing has been in English and Chinese without letting LLMs look up legal documents, which is not realistic since legal lawyers constantly reference materials. We might be underestimating what LLMs can actually do in practice. So we created our own benchmark dataset called KBL. It's about 3,000 dataset covering 3 main areas: legal knowledge, reasoning, and bar exams of Korea. Our questions are multiple choice and lawyer and law professor review every single answer. We pulled questions from all sorts of places, presidents, statues, bar exam, and even legal aid QA sets. Let me walk you through the knowledge section of KBL, especially how we test legal understanding. First, the legal concept dataset verifies whether AI can actually accurately grasp the concept in the legal domain. Next, we have two types of tasks about matching status. One where AI needs to connect legal article with what they mean, and another where it has to figure out which laws apply to specific situations. Third, AI have to determine whether a crime meets the required elements for its establishment. Lastly, in hallucination dataset, we test if LLM can spot fake laws that sounds real, catch common legal mix-up, like unique article of Korean the Kim Yong-ran acts about giving gifts to public officials, and handle tricky situations. Let's talk about how we test LLM's listening. First, we give it criminal cases where someone got hurt or died, and the LLM has to figure out if the defendant actually caused it. Second, we use precedents to see if LLM can spot when stories do not match up. You know, when victim, witness, and defendants give different testimonies of what happened. Lastly, we check if AI can find relevant past cases to support their arguments and spot when two cases are dealing with the same legal issues. Finally, the Korean bar exam time is tight, so I keep it out. Okay. We test the LLM in two ways, closed book and open book. RAG uses 220,000 Korean statues, 150,000 Korean presidents, and BN25 retrieval to patch relevant informations. The performance of models without RAG is shown here on the left, but check out the right side. With RAG, most models did better, especially with tricky reasoning. RAG has no reason score because RAG changes how the model handles reasoning task, making direct scoring invalid. Open source perform similarly to GPT 3.5 in some legal tasks, and LLMs has trouble matching status. When we let them use RAG, GPT-4 did better, but still struggle with public law. Interestingly, providing load with legal reference material did not lead to any significant improvement. We zoomed how LLMs handled the 2024 Korean bar exam because GPT-4 had not seen this exam in its training. We look at two types of questions, those that test pure laws and those that require applying that knowledge to real situations. We look at with RAG, LLMs got better at the straight knowledge of law, especially in civil and criminal law. Not much improvement in civil law, just a tiny boost in criminal law. We've got 7 tests testing legal knowledge, 4 to check reasoning skill and bar exam. We work with lawyers who double check everything to make sure it's legally reasonable. We also tested LLM with RAG. It improved efficiency, but were not universal solutions. This left QR code is our Korean dataset and paper. the right QR code is the GitHub for the evaluation tool we disclosed in the ongoing RAG system situations. That's it. And thank you.
And thanks for all the presenters in this session. Questions or any? Okay. Yeah, I mean, we have a whole workshop and we made it no longer than we planned. So if no one has any questions, then. Oh. Okay, so I would like to give another round of applause for all the presenters today and also for everyone here because you made it up until the end of the workshop. And thanks everyone for submitting that papers as always. And we would like to invite you to submit papers and attend the next edition of the workshop, which will take place in EMNLP 2025 in Suzhou, in China. And the last order of business for today is to present the best presentation award, which comes with $500 prize and the gold league certificate. The most important. Okay. So the best presentation award is given out to comparative study of explainability methods for legal outcome prediction from Eva Ranuta Stagliante, Joseph Albola, and myself.
Congratulations.
Congratulations.
Thanks, Tori. Thank you. That's the nicest one we've ever had, by the way.
Okay, and with that, I think we can conclude this edition of the workshop. Maybe we should take a photo at the end.
Yeah, sure, that works. Yeah. No, just thank you all for staying so long. Thank you for for the papers, for being part of the community, being part of the community. Stay in touch. There's going to be a next version next year, but also we said the survey as well about the workshop, what did you like, what did you like. So also provide your input, connect to Slack, and yeah, have a safe trip back home, wherever that is. And thanks to all my fellow organizers who are here today, also Catalina, who was online the whole time in Netherlands in a different time zone. Yeah.
Yeah, we get a selfie. Well, selfie plus. That's not anyone's.
No.
Oh yeah, everybody don't forget your water bottles if you're before you go.
Oh yeah, there are water bottles for the speakers, kind offer from Bloomberg, except the award they offer this. And also a reminder for for instance our sponsor Bloomberg, but also the Humanads who offer the lunch. So there's more bottles for the speakers.